When you first log in, your current working directory is your home directory. Your home directory has the same name as your username, in this case it's temp, and it is where your personal files and subdirectories are saved. To find out what is your home directory, just type ls. The ls command lists the contents of your current working directory. Please note that there may be no files visible in your home directory. That's because ls does not in fact show all the files in your home directory to be listed, but only those ones which names does not begin with a dot. Files beginning with a dot are known as hidden files and usually contain important program configuration information. They are hidden because you should not change them unless you are very familiar with Unix. To list all files in your home directory, including those whose names begin with a dot, just type ls-a. As you can see, ls-a lists files that are normally hidden. Many commands like ls and others can take options, so -a is an example of an option. Please note that options change the behavior of the command. There are online manual pages that tell you which options a particular command can take, and of course how each option can modify the behavior of the command. We will now make a subdirectory in your home directory to hold the files we will be creating and using in the course of this tutorial. To make a subdirectory called, say, dir1 in your current working directory, just type mkdir dir1. To see the directory you have just created, type ls. The command cd directory, or cddir in our case, means change the current working directory to dir1. The current working directory may be thought of as the directory you are in. For example, your current position in the file system tree. To change to the directory you have just made, type cd dir1. Type ls to see the contents of the directory. Now, an exercise for you. Please make another directory inside dir1 directory called sub1. You can pause the video, complete the task, and then play it further. Here is a solution for this simple task. Just type mkdir sub1. Now let's cd to the upper directory to dir1 and run the command ls-a. As you can see, dir1 directory and all other directories has got this special directories called dot and double dot. In Linux, dot means the current directory, so typing cd dot means stay where you are, so in this current directory. And cd double dot means the parent of the current directory, so typing cd double dot will take you one directory up. Now try to type it, cd dot dot. Note, typing cd with no argument always returns you to your home directory. This is very useful if you are lost in the system. Now try to type just cd. It will take you to your home directory. Another handy command is pwd, print working directory. If you try to type it right now, pwd, this will give you full path name to the directory you are in, and it will look something like this. The last directory is your home directory, or the directory which you are in, and all the way up to the root of the file system. Dash sign means the root of the file system. Now another exercise is looking at this result of pwd command. Try to move around using cd, ls and pwd again command to explore your file system. And remember, if you get lost, just type cd by itself to return to your home directory. Let's move on and type cd to get back to our home directory, and then type ls dir1 to list the contents of your dir1 directory. Now type ls sub1 and you'll get a message like this. The reason is sub1 is not in your current working directory. To use a command on a file or directory not in the current working directory, the directory you are currently in, you must either cd to the current directory or specify its full path name. To list the contents of your backups or some other directory like sub1, you must type ls dir1 / sub1. Home directories can also be referred to by the tilde character. It can be used to specify paths starting at your home directory. So type in ls tilde / dir1 will list the contents of your dir1 directory no matter where you currently are in the file system. What do you think ls tilde would do in your command line? So ls tilde will list your home directory, and ls tilde / will list the directory which is one level up for sure. Now please try to list the contents of the directory which is 2 levels up from your home directory. And the solution is ls tilde / /. Let's recap the commands we used in previous session. ls command lists files and directories. ls-a lists all files and directories. mkdir makes a directory. cd directory changes to name directory. cd change to home directory. cd tilde change to home directory as well. cd double dot will change to parent directory. And the final command was pwd, which display the path of the current directory. There are some more frequently used options which could be used with ls command and which we can find with the help of man command. Man is a system's manual pager which you will be using very often and which could give you a lot of information about system commands and system options. Now let's type man and ls command. As you can see, there are some parts here like name, synapses and description. You can see options descriptions down here, and you can find here all the options which you can use with ls command. To exit man pager, just press Q button. Now let me show you several popular options with ls command. ls-l shows file or directory, size, modified date and time, file or folder name and owner of file and its permission. ls-a you already know, it lists all file including hidden file starting with dot. ls-lh with combination of LH option which shows sizes of human readable format. So instead of bytes it will show you the size in kilobytes or megabytes, etc. -r option display files and directories in reverse order. -R will recursively list subdirectories. -L will display file size in order, and it will display big in size first. So you can sort files by file size with such an option. Let's create our first directory with mkdir command. This will make a subdirectory in our home directory to hold the files which you need to hold and for our testing purposes. To make a subdirectory called temp or dir1, for example, you can use this command mkdir dir1. mkdir stands, as you can guess, for make directory. And let's ls, as you can see, we have dir1 already created here. To create even more directories with one step, you can use it mkdir and then type the directory names, and that will create several directories at a time. Let's continue with mkdir command and have some more options reviewed with this command. As you remember, mkdir makes a directory in the folder you are in. Let's take a look at contents of the folder and see that we have directory 4, directory 3, which we've created before. But what if we want to create a directory with subfolder in it? So you'd have to create a directory, then change your location to this directory and create the subfolder. But p parameter makes it for you. To create subfolder inside of directory 5, you can use this parameter -p. But how can we check that it is created? R capital R gives us recursive view of the folders. As you can see, it gives you recursively the contents of the folders, and our folder dir5 with subfolder in it. As you can see, sub1 is created inside dir5. So let's have a look at help file. Another way of taking some help is command -- help, and this will give you some short version of help. As you can see, it's shorter than man mkdir. So let's take a look at it. As you can see, here we have /m and /p parameter, which can be very handy when you want to create subfolders in it. Also, a good parameter is /v. It will give you a result of creating folders. So if you want to see if these folders are created for sure, you can use this parameter /verbose. It will give you the result that your directory is created for sure. As you can see, our folders are created. Let's start moving around the operating system. For this we use cd command. Let's list the contents of the current directory to get better view. And cd command stands for change directory. The command cd directory means change the current working directory to the directory which you want to change. The current working directory may be thought of as the directory you are in, for example, your current position in file system. And cd double dot will move you one level up. So to move one level up from where you are, you type cd dot dot. Cd dot dot will get you once more one level up, and you can check it with this part of the command line indicator. So / means root of the file system. Let's list it and see the contents of the root. This is the contents of the root, and we can list it with ls command, as you can remember. So now let's move around even more and change directory to /usr directory. Here we are, and the indicator shows us that we are in usr directory. Let's list it and see the contents of it. Let's move to local directory. cd /usr/local will get us to the local directory. Let's list it again. Please remember that this way of typing means absolute link to it, and you can use relative way of typing, like cd lib without /usr lib. Just typing cd lib will get you to the subfolder of the folder which you are in right now. cd dash will get you one level up. So you were in lib, it gets you one level up. Let's list it again. And cd dot will get you one level up as well. cd dot will get you two levels up, and so forth. You can type it whatever number you need. cd, this sign will get you to your home directory. So no matter in which directory you are right now, cd tilde will get you to your home directory. And tilde means also that you are in your home directory, as in this right side of the left side of the command line. Let's play even more. ls / will get you to the root of your operating system, and we can list this with any directory. So you can list the contents of any directory if you want to know which directories exist. ls /home temp will list the contents of temp, and you can also use tab button to complete your command line. Like if you don't want to type it anymore, you can type one letter, then press tab, and it will finish the command for you. So you can use tab to help you. So let's change the directory to cd usr with tab. So you just begin to type u, and tab will finish it for you, usr. Let's list the contents of local folder, and as you can see, it successfully lists the contents and helps us to find what directory we want to move to. And tilde will get you to your home directory. Another helpful command is pwd. Pwd shows your directory in which your current directory. So as you can see, in this case we have / to remind you it's the root of a file system. So the path always begins with /, and then we have home directory and temp directory. If you type it in such a way, it means this is an absolute path to the directory. We also have another way of changing directory is relative way. So if we type it like this, cd temp, it means that we type a relative path path to the directory we want to. You can also change directory to your home directory with this sign, as you remember, and you can list the contents of the home directory with ls command. Let me give you some more tips which will help you to move around. Tab button completes the command for you. So if you press tab button, it will automatically complete the command for you or give you some possibilities of completion. Up arrow gets the previous command from the commands history list. If you press up arrow, it will get the previous command from this list. And down arrow will get the next command from the commands history list. If you type some commands and you press up arrow, it will get the previous command, and if you type down arrow, it will get the next command. So let's practice tab button. As you can see, I've double pressed tab button, and it gave me 143 possibilities. So when you double press the tab button, it gets all the possibilities which can be for completion of the operation. In this case, etc gets too many directories and gets too many possibilities. Let's try to cd home temp directory. It will give less possibilities, like all of them could be listed. So let me try to type dir and double press tab, and it gets just 6 possibilities for completion. And if we, as you can see, if we press up button, it gets all the previous commands, and down button gets, as you can see, all the next commands. Let's create a new file with touch command. Touch creates a new file, a new empty file. We will create it in dir1. Let's change directory to dir1, list its contents with ls, and create a file. Touch, then goes a file name. Let's check it. Here it is. If you want to create several files, several empty files at once, you just specify the files names after touch command, and it will create those files. Let's check it. Let's ls, and here they are. Let's check files properties with la command, and here they are, and they are empty. Timestamp is present, and let's check touch help. There are some more different options for this command, like A changes only the access time. Then we have C, it won't create a file. C option means that it won't create a file if such a file is already there. -T, and then we have to specify time. It will create a file with specific time instead of current time. And M parameter modifies just time. If we want to move files, let me clear the screen, we use move command. Move command moves the file to the specified directory or renames these files inside of the same directory. So if we use move file 1 and file 2 inside of the same directory, it will rename the file to the specified file. Like in this case file, it will be renamed to moved file. Let's perform these operations inside of dir1, and let's check it. Here is the file which we've moved, so we've just renamed it. If we want to move some specific files to another directory, we have to specify the address of this directory. Like if we want to move moved files to home/temp/dir2 directory, we need to specify this address and specify the new file name or the same file name. So in this case it will be new moved file. Sorry, I have to change it like this, yes. And this will move a moved file and rename it at the same time to dir2. Let's check it if it is there with ls command. ls and dir2 will show us that it is there and it has been moved and renamed. So if we want to, yes, let's check the stamps. It just was moved and you can see that it has all the properties of the file which was previously. So let's create some more files to play around with them. We will create 3 files with .txt extension to show you one more trick with move. If you want to move all the files with say txt extension or maybe some other extension, you just specify it with asterisk and then .txt. So it will move all the files with txt extensions to dir2. Here they are, and it spares our time if we want to move bunches of files. And if we want to move file 1 one level up, we can use // and we can use 2 levels up, 3 levels up, the quantity of levels we need right now. So it moves the file 2 levels up. Now if you want to copy a file, it works pretty much the same as moving files, but you have to use cp command. Cp command copies file 1, for example, to some other file. Let's call it file 1 copy. So if you are copying inside of one directory, you just specify first file name and the second file name and use cp command. Here it is. But if you want to copy file 1 to some other directory, you have to specify this directory like with move command. So we will copy file 1 to home temp dir2, and file's name will be file 1 copy 2. So this will copy file 1 to file 1 copy 2. I've made a typo here. You have to use cp command, not cd. And that copies the file. Let's check it with ls command. Let's ls home temp dir2 and see if it is there. Here it is successfully copied. If you want to see more properties of the file, please remember to use la option with ls command. We've already created, moved and copied files. Now let's remove files. To remove files you use rm command. This will remove the files. Let's check what we have here. Let's say we want to remove file 1 copy. So we use rm and file's name. This will remove this file. Let's run it and check if it is removed. No file anymore. No file 1 copy. If you want to have help, you can get it with --help and see what other options do we have. We can prompt before every removal, and we can also see the result of removal. Let's try to remove file 1, for example, with verbose option to see what was the result. So to see the result, we use --verbose, and here it is. It removed file 1. Let me clear the screen. So let's change our directory to home directory. Let's alias it. And what if we want to remove directory? To remove directory, you use rmdir command. This will remove the directory. But please note that it removes only empty directories. It removes directories without any files. So let's try to remove directory 6, dir 6, using rmdir dir 6. And here is a result. A directory is not empty. That's why we couldn't remove it. Let's change directory to dir 6 and try to see what is there. This another directory doesn't allow us to remove dir 6. Let's remove it. rmdir sub 1 will remove it. Let's change the location and try to remove it now but with verbose option to see the result. Sorry, not cddir, but I have to find rmdir. Let's run it once more. rmdir, yes. And as you can see, rm doesn't allow us to remove a directory. Now we've completed this task and have a result because of verbose option. And this directory is gone right now. Let's change directory to dir2, list the contents, and try to remove all the files with txt extension. To remove all the files with some extension, you use *.txt. This will remove all the files with txt extension. And what if we want to remove all the files? We use just *sign. This will remove all the files. Let's use it with verbose option to see the result. Removed file 1 copy, removed new moved file. Let's check it. No files here. Let's change directory and try to use this *sign with rmdir. See if we can remove all the directories in this dir. Failed to remove only 2 directories because they are not empty. Please remember that you cannot remove directory if it is not empty. But dir2, dir4, dir3 was removed successfully, and these ones were not empty. To see who is on the system with you type who. One method to get a sorted list of names is to type who and output it to some file. Let's call it names.txt. Then let's type a command sort and input from names.txt. This is a bit slow, and you have to remember to remove some files which you don't need, or some temporary files. What you really want to do is connect the output of who command directly to the input of the sort command. This is exactly what pipes do. The symbol for a pipe is a vertical bar. For example, type in who, vertical bar, sort, will give the same result as above, but quicker and cleaner. To find out how many users are logged on, type who, vertical bar or pipe, word count -l. The asterisk wildcard. The character asterisk is called a wildcard and will match against none or more character or characters in a directory of file name. For example, in your home directory type ls file and then asterisk symbol. This will list all files in the current directory which start with file. You can put asterisks before the file name, then it will find everything that is symbol. The question mark wildcard, this character question mark will match exactly one character. For example, if you want to find all the files which are named files, but you don't know which file number you exactly need, then you should type file question mark. It will find all the files but without one symbol in the end of the file name. As for file name conventions, we should know here that a directory is merely a special type of file, so the rule and conventions for naming files apply also to directories. In naming files, characters with special meanings such as dash, asterisk, question mark, etc. should be avoided. Also avoid using spaces within names. The safest way to name a file is to only alphanumeric characters, that is, letters and numbers, together with underscore and dot symbols. File names conventionally start with a lowercase letter and may end with a dot followed by a group of letters indicating the contents of the files. For example, text files should be named .txt in the end. Then, in order to list all files containing txt or text in your home directory, you need only type ls *.txt in that directory. Now let me mention several words on getting help or online manuals usage. There are online manuals which gives information about almost all commands. The manual pages tell you which options a particular command can take and how each option modifies the behavior of the command. We already used man command, we can use it once more. Let's type man and some command, for example ls, or you could just type man command to read the manual page about man command. To exit the command we just type q as I've mentioned. For example, we can find out more about wc or word count command. Let's type man wc. Alternatively, you can type what is wc. This gives an online description of the command, but omits any information about options and etc. Or you can type a command, then a space --help. When you are not sure of the exact name of a command, just type apropos and keyword, and this will give you the command with keyword in the manual page header. For example, try typing apropos copy. Now to recap this lesson, asterisk symbol matches any number of characters. Question mark symbol matches one character. Man command reads the online manual page for a command. What is command? Brief description of a command. Command space --help will also give you brief description of a command. Apropos keyword match commands with keyword in their man pages, like apropos copy, for example. Some words about file system security or access rights. In your home directory type ls-l for long listing. You will see that now you get lots of details about the contents of your directory. Each file and directory has associated rights, access rights, which may be found by typing ls-l. Also, ls-lg gives additional information as to which group owns the file or directory. In the left-hand column of a 10-symbol string consisting of the symbols D, R, W, X, dash, and occasionally S or capital S. Now, if D is present, it will be at the left-hand end of the string and indicates a directory. Otherwise, dash will be the starting symbol of the string. The 9 remaining symbols indicate the permission or access rights and are taken as 3 groups. The left group of 3 gives the file permissions for the user that owns the file or directory. The middle group gives the permissions of the group of people to whom the file or directory belongs. The rightmost group gives the permissions of all others. The symbols R, W, etc. have slightly different meanings depending on whether they refer to a simple file or to a directory. Now let's switch to access rights on files group. R or dash indicates read permissions or there is no read permissions, that is, the presence or absence of permission to read and copy the file. W indicates write permission, or if we have dash, that is, there is or there is no permission to write or change a file. And X indicates execution permissions, that is, the permission to execute a file where appropriate. And the last one is access rights on directories. R allows users to list files in the directory. W means that users may delete files from the directory or move files into it, and X means the right to access files in the directory. This implies that you may read files in the directory provided you have read permission on the individual files. So in order to read a file, you must have execute permission on the directory containing that file, and on any directory containing that directory as a subdirectory, and so on, up the tree. For example, dash rwx rwx rwx. This is a file that everyone can read, write, and execute and delete. And if we have dash r, w, and all dashes, a file that only the owner can read and write. No one else can read or write, and no one has execution rights. For example, your mailbox file. Now let's move on to changing access rights. Change mode or changing a file mode will help us in this. Only the owner of a file can use change mode to change the permission of a file. The options of change mode are as follows. U stands for user, G stands for group, O stands for other, A stands for all, R for read, W for write and delete, X for execute and access directory, plus add permission, minus take away permission. For example, to remove read, write and execute permissions on the file example, for example, I don't know, file permission, let's call it. And for the group of others, type change mode go-rwx and permissions file. This will leave the other permissions unaffected. To give read and write permissions on the file permissions to all, let's type change mode a plus rw file permission file. Now a task for you. Create some file and name it and try changing access permissions on the file and on the directory it is in. Use ls-l to check that the permissions have changed. You can pause here and get back to this lesson later when you are done with your task. Now I hope you have performed this simple task, and now let's switch to processes and jobs. Let's shift to processes and jobs. A process in an executing program identified by a unique PID or process identifier. To see information about your process with their associated PID and status, type PS. A process may be in the foreground, in the background, or be suspended. In general, the shell does not return the Linux prompt until the current process has finished executing. Some processes take a long time to run and hold up the terminal. Background in a long process has the effect that the Linux prompt is returned immediately, and other tasks can be carried out while the original process continues executing. Now let's run some background process. To background a process, type $character at the end of the command line. For example, the command sleep waits a given number of seconds before continuing. Now let's type sleep 10, sleep space 10. This will wait 10 seconds before returning the command prompt. So until the command prompt is returned, you can do nothing except wait. To run sleep in the background, type sleep space 10 space $character. The ampersand runs the job in the background and returns the prompt straight away, allowing you to run other programs while waiting for that one to finish. Take note that the user is notified of a job number or number from 1, and this number is enclosed in square brackets together with a PID and is notified when a background process is finished. Backgrounding is useful for jobs which will take a long time to complete. You can background a current foreground process. At the prompt, let's type sleep space 1000. You can suspend the process running in the foreground by typing Ctrl-Z. So please hold down the Ctrl key and type Z. Then to put it in the background, just type BG. And also please note, you shouldn't background programs that require user interaction. For example, text editor. Now we can of course list suspended and backgrounded processes. When a process is running backgrounded or suspended, it will be entered onto a list along with the job number. To examine this list, just type jobs, so let's type it. And we have an example of a job list which you can examine. And to restart or foreground a suspended process, type foreground space $character and job number. For example, to restart sleep 1000, just type foreground space %1 or whatever letter you have. Number. I'll type my number. And also please note that typing FG or foreground with no job number foregrounds the last suspended process. Now we have a special command to kill a process. To kill a process we use kill command that will terminate or signal a process. It is sometimes necessary to kill a process, for example when an executing program is an infinite loop. To kill a job running in the foreground, just type Ctrl-C. For example, run Ctrl-C when you run sleep 100 process. Let's do it. Let's type sleep 100 and now press Ctrl-C. To kill a suspended or background process, type kill, then space, % and job number. For example, run sleep 100, space ampersand, then run jobs. If it is job number like this one, just type kill, space %4. Let's do it. Let's kill this job. To check whether this has worked, examine the jobs list again. So let's run jobs command again. PS or process status command also could be used for processes that could be killed by finding their process number or PID PIDs and using kill PID number. Like in this case, we can type sleep 1000 space ampersand, and now let's find this process by typing PS, and we can find PID of this process. Now we know what process to kill, so to kill this process just type kill and its number. Let's do it. And also let's type PS to see if it is removed from the list. If a process refuses to be killed, use -9 and the process ID. Please also note that it is impossible to kill off other users' processes. And now let's recap the commands we had during these 2 sessions about user rights and processes. ls-lag lists access rights for all files. Change mode, options, and the file we want to change access rights for named file. Command ampersand runs command in background. Ctrl-C kills the job running in the foreground. Ctrl-Z suspends the job running in the foreground. BG or background backgrounds the suspended job. Jobs shows list of current jobs. Foreground %1, for example, foregrounds job number 1. Kill %1 kills job number 1. PS lists current processes. And kill and then the job's number kills process number which you specify. Let's take a look at some small but still very handy commands. First command is echo. The echo command prints its argument to the standard output. Let's type echo hello world, for example. That will give us an output of this text we've typed. The echo command is very useful for finding expansions of shell globs like wildcards such as asterisks, and variables such as $home, which you will encounter a bit later. Next command is diff. Diff is a very handy command as well. To see the difference between 2 text files or directories or some other files, you can use this command. Several options can control the format of the output, and the default output format is often the most comprehensible for humans. However, most programmers prefer the output from diff-u when they need to send the output to someone else, because automated tools can make better use of it. So let's try to type diff and compare 2 directories, for example. Let's type diff dir1 and dir2. As you can see, we have some differences in these directories, and the differences are specified here. Let's now compare with diff. Let's type diff file1 and names.txt. And we also see the difference. We can also use -q option to see the quick results. Let's move on, and the next command is file. If you see a file and you are not sure if it's of its format, try using file command to see if the system can guess. Now let's try to type file and some file name. In my case it's names.txt. We can also check file and directory. Let's type file dir1. If we are not sure if it is directory, it will show us that it is directory. So this command can show you any format of any file, and it's sometimes can be very useful. Sometimes you need to identify your hardware and to know what kind of wireless card or network card your laptop or server is using. Linux gives a relatively straightforward way to get this information. Just type ls-pci-v command and this will give us the hardware used in your system, from wireless cards to memory and graphic cards. Though it's not that easy to read, but if you scroll down the list you can look for words like network or video card or graphic card, and you can get the make and the model of your wireless or network card. You will also see a line that says kernel driver in use. This is a very important line for your information which driver is used for this or that hardware. A driver is a piece of software that allows the Linux kernel to talk to your hardware. Drivers exist in all operating systems, but they are usually installed by the hardware manufacturer. In case of Linux, in Ubuntu Linux, it automatically handles the installations of drivers, looking at what you have and installing what you need. But sometimes the wrong driver are installed, that causes the technical issues. If you have any issues with drivers, you already know what driver it is using and which drivers are controlling what hardware. So you can use this command ls-pci-v and it includes not only the hardware but also the driver interacting with the hardware. This is helpful for troubleshooting in that you can research if there are known issues with certain drivers and certain pieces of hardware. This command ls-pci-v gives you all the information you need, your hardware and the driver associated with it. A brief information about changing your password command, just to mention. Use passwd or password command to change your password. Now try to type this command passwd and then you'll be asked your old password, then prompted for your new password twice. Choose some password and change if you need to. Now let's move on and take a look at environment and shell variables. The shell can store temporary variables called shell variables. They can contain the values of text strings. Shell variables are very useful for keeping track of values in scripts, and some shell variables control the way the shell behaves. To assign a value to a shell variable, use the equal sign. Let's type it. Let's assign a variable temp some information like temp is a demonstration user. Let me type it. Temp equals demo user. This example sets the value of the variable temp to demo user. To access this variable, use $temp. For example, try running echo $temp. Environment variables are useful because many programs read them for configuration options. An environment variable is like a shell variable, but it's not specific to the shell. For example, you can put your favorite less command line options in the less environment variable, and less will use those options when you run it. Some words about the common path. Path is a specific environment variable that contains the command path, or path for short. A command path is a list of system directories that the shell searches when trying to locate a command. For example, when you run ls, the shell searches for the directories listed in path for the ls program. If programs with the same name appear in several directories in the path, the shell runs the first matching program. If you run $path, you'll see that the path components are separated by colons. For example, let's type echo $path and take a look at it. Now, as you can see, the first in my path is dir. That's why I've added it. For example, you can add this command with the command a directory, dir or some other directory, to the beginning of the path, so that the shell looks in dir before looking in any of other path directories. Let's try to add it once more, though I have it already. Let's type path, all capitals and all capital letters, equals dir 1 colon and $path. Or you can append a directory name to the name of the path variable, causing the shell to look in dir 2 or in dir 1, last. So you can type path equals $path colon dir 1. Let's type it. Path equals $path colon dir 1. All path is capital letters. Be careful when modifying the path, because you can accidentally wipe out your entire path in your mistype all capital path. If this happens, it isn't a large problem, because when you close your shell and just start a new shell, all will be as usual. So if you mistyped somehow or had some problems with typing your path, just close your terminal and reopen it once more. Special characters. Special characters are important in Linux and you have to know them. Let me take a quick look at them and list all of them, at least some of them. Asterisk, special character. Then comes dot, special character. Exclamation mark, pipe, slash, backslash, $, or just $, tick, and backtick, double quote, caret, tilde, hash, square brackets, braces or curly brackets, and underscore. Asterisk is used for as glob character. Dot is used for current directory, file host name, delimiter. Ban or exclamation mark is used for negation, or it's used in command history. Pipe, you know already this character. Forward slash or just slash is directory, delimiter or search command. Backslash is used in literals or macros, but it's never used in directories. Dollar is a variable denotation or end of line. Tick, literal strings. Backtick is used in command substitutions. Double quote is used in semi-literal string. Caret is used in negation or beginning of line. Tilde is used in negation or directory shortcut. Hash is used for commands or preprocessor or substitutions. Square brackets is used in ranges. Braces or curly brackets are used in statement blocks or ranges as well. And underscore or under is a substitute for a space. Well, I admit that it's not a fun, but you have to know all the names of these characters. Now let's switch to command line keystrokes. They are also good to know. We have many command line keystrokes, and let me list some of them. Ctrl B moves the cursor left. Ctrl F moves the cursor right. So let's practice a bit. Let me type some command here, or I'll just take some command from the history with up arrow and move around a bit. So Ctrl B, let's use it. Let's press Ctrl B. As you can see, our cursor moves left. Ctrl F, our cursor moves right. Then we have Ctrl P. It shows us the previous command in the list. Ctrl N views the next command if we have the next one. Ctrl A moves the cursor to the beginning of the line. Ctrl E moves the cursor to the end of the line. Ctrl W erases the preceding word. Ctrl U erases from cursor to beginning of line. Ctrl K erases from cursor to end of line. Ctrl Y pastes erased text. So you can practice these keystrokes in your terminal and see how they work. If you know them well, that will help you a lot in your future work. Take a look at this table and try to move around in your command line and practice some of them. Command chaining operators. Command chaining operators can help you much while running commands. Remember ampersand operator, so we used it to background some job. We just type a command and then ampersand operator, and the command runs in background. You can also execute more than one command in the background in a single go. Run one command in the background, then you can type, for example, one command, ampersand, another command, followed by another command, and again ampersand. This will run these two commands in the background. Another good to know operator is semicolon operator. Semicolon operator makes it possible to run several commands in the single go, and the execution of command occurs sequentially. Let's try type ps semicolon ls semicolon e and pwd. The result is that the first command to execute, and then we execute the second command and the third command in one line. Next operator is AND operator. The AND operator, you type it like this, would execute the second command only if the execution of the first command succeeds. So it won't execute the second command if the first command fails. The exit status of the first command has to be 0 or a success status. This command is very useful in checking the execution status of last command. For example, we want to check file.txt with file command, and only if this command runs successfully and we can check this file.txt and this file exists, then we perform the second command and can read it with cat file.txt. So now let's run this command, file1.txt, and then type AND operator, and then let's try to read it with cat command. So as you can see, it fails because file1.txt doesn't exist. Now let's perform this operation with existing file. Let's type file.txt, AND operator, and cat file.txt. It runs because the first command is successful, then the second command runs as well. OR operator. The OR operator, it is type like double pipe, is much like the else statement in programming. The above operator allows you to execute second command only if the execution of first command fails. So again, with our previous example, let's try to run file1.txt or cat file1.txt. In this case, it will run because the second part of this command will run because the first command fails. Not operator, it is typed with exclamation mark. The not operator is much like an except statement. This command will execute all except the condition provided. To understand this, let's create a directory test and cd to it. Now let's create several files in this directory with touch command. Let's type touch file1.doc, file2.doc, file3.pdf, file4.xml, and file5.html, and file6.html. Now to create all the files in this directory except PDF, let's say we don't want to remove all the files in this directory except PDF. Let's say we don't want to remove these files. We can type rm-r exclamation mark open brackets *pdf close brackets. Let's check it with the ls command. And or operator. A good example is to check some host and pin it. If pin is up, you just have to echo that the host is up, and if the host is down, please echo host down. Let's try to pin some host, for example, pin-c 3 hops to www.go.com and echo up. Or if the host is down, echo host down. Linux stop command is used to show all the running processes within your Linux environment. Let's type this command top and review all the information which goes with it. Let's start with the line 1. Line 1 shows time, how long the computer has been running, number of users, and load average. The load average shows the system load time for the last 1, 5, and 15 minutes. Let's go to the line 2. Line 2 shows total number of tasks, number of running tasks, number of sleeping tasks, number of stop tasks, and number of zombie tasks. Line 3 is all about CPU usage. The first one shows CPU usage as a percentage by the user. Then goes system usage, low priority processes, idle processes, I/O wait, hardware interrupts, software interrupts, and still time. Line 3 is about system memory. The first one is total system memory, then free memory, memory used, and buffer cache. Line 4 is about swap. Total swap available, total swap free, swap used, and available memory. As for main table, we have process ID first, then user, priority, nice level. We will talk about nice a bit later. This is very useful feature in Linux, but for now just take note that the fourth column is about nice level. Then goes virtual memory used by process, resident memory used by a process, shareable memory, CPU used by process as a percentage, memory used by process as a percentage, time process has been running, and command. You can keep the top command easily available without having to type the word top each time in your terminal window. Remember, we talked about putting commands in background. So let's put it with Ctrl-Z. And to bring top back to the foreground, just type FG, foreground. Let's do it. FG. As you can see, it is again here. But I'm not sure if it is easier to type top or put this command into background and then put it into foreground. I guess that you have different purposes, and for each purpose you can run the command in the way you need it. Some key switches for the top command are -H will show the current version. Let's type the following command to show the current version details for top. Top-H. And here comes the version we are using right now. If you want to specify a delay time between screen refreshes, you can use top-D. To specify the delay between every 5 seconds, just type top-D and 5, and it will refresh every 5 seconds. You can also show only the process that is specific for a specific user and is running by this user. To do this, you can type top-U and username. Let's type it. Top-U, and in this case it will be user temp. And we have the output of all the processes run by user temp. By the way, to exit top, you just press Q button. Then we have an option to hide idle tasks. The default top view can seem cluttered, and if you want to see only active processes, you can use the command top-I. So let's run this command, top-I. As you can see, it shows all the active processes and hides idle tasks. You can also adjust top's view. For instance, if you hit L, it will hide the first line, uptime and load average line. Let's do it. Let's hit L. And it is hidden. If we hit T several times, it will hide tasks and CPU information. Let's do it. Let's hit T several times. And it is gone. Let's redo it to show it again. The same with M letter. So let's hit M, and it is also gone. Some words about main window. You can sort the outlook of top command by hitting different keys. For example, by default it is sorted by CPU usage. If you want to sort by time usage, you can hit capital T. Let's do it. Let's hit capital T. If you want to sort by process number, you can hit capital N. Let's do it. Let's hit capital N. If you want to sort it by memory usage, you can hit capital M. That will sort the outlook by memory usage. Let's do it. And if you want to get back to the default view, you can hit capital P. This will return the outlook of the top command to the defaults. Another handy key is N command. By hitting N command, you can adjust the processes, the number of processes you want to view. By default, top shows you so many processes that can be displayed on your screen. If you want to view some other number of processes, you can hit N, and now you can enter the number. Let's enter 5, for example. As you can see, it shows now only 5 processes. If you want to get back to the defaults, you can hit N again and enter 0. This will get back to the defaults. Let's do it. You can also hit H for help for this top command help file. Also, you can play around with colors. For example, hitting Z will change the colors to red, and hitting capital Z will show you the different options for colors. For example, if you want to change the target, the current target is T capital, and it is for time, and then you want to change time, for example, to, let's say, green. Let's hit 2. It's for green, and then you want to commit this change. Let's hit W, and to commit and we hit enter, and as you can see, the color scheme is changed. So, but please remember, when you exit top, let's do it by hitting Q and run it again. The scheme will be default scheme. So that's it for about top command. Play around with it. It is a very useful command to monitor all the processes and what's going on in your system. To display calendar, you can use cal command. It's very useful and has a lot of options. Let's type it cal, and it will show the today's date. If you want to check the whole year, you can type cal and then the year you need, for example, 2018. This will show the calendar for the whole 2018 years. If you want to check out some date, some specific months, you can specify the number of months, for example 2. Let's type cal 2 2018. This will show the February of the year 2018. You can also check the days in days-based calendar, and for this you have to specify cal-j parameter. This will show the day's number. To display 3 months, you can type cal-3. This will show 3 months, previous, current, and next months. You can combine it with year. For example, cal-3, then we have to specify months, for example, the second month, February, and the year 2018. This will show January, February, and March. If you want to display the number of months after the current month, you can specify it with dash capital A and the number of months you want. For example, cal-dash capital A2 will show you 2 months after the current month. And the same with dash B, capital B. So cal-dash capital B2 will show you 2 previous months. There is another version of cal command. It is called newcal or ncal. Ncal can show you some additional parameters, some additional information which could be useful for you. For example, you can view the current week number. For this you have to type ncal-w. Let's do it. Let's type ncal-w and we can view the week's number, which are printed on the bottom of each month. So do some practice with calendar. It could be useful in script writing or some automation tasks. Another useful command related to calendar command is date. Date command will show you the current date. Let's run it. Let's type date. It shows you, as you can see, the current date on the system. If you want to check a date for some specific day, you have to specify this day, like date dash d in quotes 2018-09-09 quotes. This will show the date for the 9th of September of year 2018. You can also use time strings like date-d now, date-d today, yesterday, tomorrow, Sunday, last week, next-week, last-month, next-month, and last-year, etc. So let's run, for example, date-d next-year. It reveals the information about the date which will be a year ahead. There are lots of tokens which date command supports. For example, you can use date command with plus character. Let's type it date plus percentage character and capital U. This will show the week's number. We can also provide date with the formatting string by prefixing it with a plus sign. Let's do it. For example, let's type date plus quotes week number colon space percentage character capital V space year colon space percentage character Y, and we close the quotes. It could also be very handy when script writing. You could use different date formats or use dates to find some files which are older than some date and delete them or copy them and modify them or archive them. There are plenty of such formatting options, and these formatting tokens you can check them in man date and practice a bit with them. Let's check it. For example, let's do some examples more. Let's type man date. Here they are, and we can take, for example, this U token. Let's exit man help and type date plus percent character and U. This will show us the day of the week. So you get the idea how you could use this date and cal commands in your scripts or automating your administrative tasks. To log off from console and the shell, you can use exit command. So this command will terminate your activity in the console and log you off. Let's run it to see how it works. And it logs you off immediately. To reboot the machine, we use reboot command. This will reboot the computer immediately. So let's try typing reboot and hit enter. And the warning appears that authentication is required to reboot the system. Please note that you have to have privileged rights to reboot or shut down the system. Here it is mentioned that you must be root to do this. To power off the system, you basically use the same command. Let's type power off, and it's the same as with reboot command. You have to be authenticated to do this operation. You have to be root to do this. Another command to change the state of your computer is shutdown. Shutdown command does pretty much the same as log off, reboot and power off. So you have different options to use with shutdown. Let's check man shutdown. -H halts the machine, so it powers off the machine. -P do the same, so it's also powers off the machine. -R reboots the machine, and you can specify the time when it should be rebooted. For example, if you type shutdown -R and specify now or 0, it will do the operation, the command immediately. And if you type shutdown-r and specify some time, for example 5, it will shut down, it will restart the system in 5 seconds. So you can plan the reboot or the halt of the system when it is needed for you. After you open a shell, the shell environment is set up based on the user who started the shell. Bash shell settings for all user shells are located in several files. You can make your own version of these files to override the system settings. There are two types of files holding these settings: startup files and initialization files. Bash runs startup files for any shell that is a login shell. These files define settings that apply across your entire login. Bash runs initialization files for shells run interactively. So Bash uses the file's wide startup file, which is located in etc profile directory, and several dot files which are located in user's home directory for personal settings, if they exist, such as .bash_profile, .bash_login, and .profile. And it also includes scripts stored in etc profile.d directory. That's as for Ubuntu Linux. When you exit from a login shell, any commands in your home directory .bash logout file are executed. You can also change your shell environment, and to do this you have to be a superuser in your operating system. About acquiring this Sudo or superuser privileges we will talk a bit later. That is done with Sudo command. But now let's talk about Bash history. Bash is the shell which is used by default by most modern Linux systems, and several operating systems which are running Linux run some other shell environment other than Bash. Also, it is run in such operating systems as Mac operating system 10. So Bash has a history feature that lets you review, change, and reuse commands which you run in the past. When Bash starts, it reads the .bash history file which is located in user's home, and it loads it into memory. This file is set by the value of $hist_file all capital. During a Bash session, commands are added to history in memory. When Bash exits, history in memory is written back to the .bash history file. The number of commands held in history during a Bash session is set by $hist_size variable, while the number of commands actually stored in the history file is set by $hist_file size. Now let's take a look at these variables with this command echo $hist_file, $hist_size, and $hist_file size. This shows the location of .bash history file, as you can see, and it shows hist size obviously and history file size. So on this operating system it's set to 500. To list all the entire history, just type history. Let's do it. To list a previous number of history commands, follow history with a number. For example, if you want to see only previous 5 commands in your history, just type history 5. Let's type history 5. To move among the commands in your history, use the up arrow and down arrow keys. Once a command displays, you can use the keyboard to edit the current command, like any other command. Left arrow, right arrow, delete, backspace, and so on. There are some other ways to recall and run commands from your bash history. If you type a double exclamation mark, that will run the previous command. If you type, let's type double exclamation mark. See? And if you type exclamation mark and the number from history file, that will run the command number. Let's run, for example, exclamation mark and 500. That will run the command number 500 from history. You can also append to this command. For example, you can type exclamation mark 500, then asterisk txt. This will append asterisk txt to command 500 from history. If you type exclamation mark, question mark, let's say capital C, capital F, and question mark again, that will run previous command line containing the capital C and capital F string. Let's do it. Let's type question mark, exclamation mark, question mark, capital C, capital F, question mark. If you type exclamation mark ls, that will run the previous ls command. Another way to edit the command history is using the fc command. With fc, you open the chosen command from the history using Nano Editor. We haven't looked at Nano Editor yet, but it's quite simple and user-friendly, opposite to Vim Editor. So it's quite straightforward here to edit and save the changes. So in Nano, type your changes and then type Ctrl-O and Ctrl-X to save your changes. The edited command runs when you exit the editor. For example, change to a different command. Let's say we can type fc 500. This will edit the command number 500, then run it. If you type just fc, this will edit the previous command and then run it. And you can also use Vim if you are used to Vim. Just type fc-e /user/bin/vim and then the command number, for example 500. This will use Vim to edit command 500. You also can use Ctrl+R to search for a string in history. For example, typing Ctrl+R followed by the string ls results in the following. Let's type it. Ctrl+R ls, so it shows us the command with ls. And another very useful command is history-c. Let's type history-c. This will clean the current history for the current session. But please note that it only clears the history for only just current session. If you exit the session and then enter a new session, your history will appear again. You use the alias command to set and list aliases. Some aliases are already set in the system-wide user-specific shell, and you can view them and print the list of aliases that are currently set with alias command. So let me change to another user, but first let's check under this user and run this alias command. As you can see, this user doesn't have any aliases yet. We will set some of them a bit later, but let's see how it is for another user. For root, for example, let's change the user with sudo -s will change for root user and run this command, alias. So there are several different aliases for different commands. As you can see, we have alias for L, which equals to ls-cf capital, or li is equal for ls-a, etc. So you can set any alias which is suitable for you. Now let me exit from this mode, from Superuser mode, and make and set some aliases. So as I said, you can define your own aliases for the current bash session, and let's do some this task. So let's type alias la equals quotes opening ls-la quotes close. And that will define this alias for just this bash session. And if you want the definition to occur for each new bash session, just add this to this line to your .bashrc file, which is located in your home folder. Let's take a look at it. With cat command, let's type cat /.bashrc. And here comes the contents of this file. We already have some aliases for this user in place, and we can add some more aliases to permanently run for this user for any session, bash session. And vice versa, if you want to remove some alias, just remove it from here. If you want to remove alias for this current session, you can use unalias command. So by typing unalias la will unalias the previously aliased la command. And if you want to remove all aliases for all commands for this session, you can unalias-a. This will unalias all aliased commands. If you need to keep an eye on a command whose output is changing, use the watch command. For example, to keep an eye on your load average, you can use the following command: watch quote cat /proc/load average unquote. Let's run this command, and it gives us an output of load average every 2 seconds, as you can see. If you want to change it, you could use -n command, -n option. But first let's quit from here. To quit, you use Ctrl+C as usual. And to change the refresh rate to 10 seconds, type watch -n10, and for example for command ls-l. And it's quite hard to see the changes. If you want to highlight the difference between screens, which is very useful, I guess, you could type watch-d option to see the changes. And now let's do some experiment. Let's type watch-d. We will take a look at the contents of the file.txt with cat command, so let's run it. And in another session, in another shell, let's do some changes to this file. Let me open another shell and type nano file.txt, and let's do some changes here, on the second line. Let's type some additional info. Let me type it, and let's reopen the first session and see what has changed. And as you can see, we have the change here. The command watch successfully shows us the change to this file. It could be very handy if you have some shared file and want to check for differences or for changes in this file. You can watch it live, so to say, and see live all the changes. You can also use this watch command to check for some changes of the file in size, for example. For example, if you want to watch some large file named iso.iso, or file1.iso as it downloads, you could use this command watch ls-l file1.iso and see all the changes and how the size is growing. Another useful command is tail. You could watch the contents of a plain text file grow over time. This is handy when you are watching the messages from logs files. You could use tail command to watch some log file for some specific program and see those messages displayed on your screen live, so to say. So to do this, let's type sudo tail-f and let's watch for syslog messages. Let's type /var/log/syslog. This will show us all the changes, and the changes are made while some lines are added to this file. So you could use even separate shell for some changes, for some commands which are important for you. For example, some log messages, some changes to the file, some changes to the critical messages, etc. And check these shells whenever you need it and see the changes. When you open a shell, you are able to run commands and access files and directories based on your user or group ID and the permissions set for those components. Many system features are restricted to the root user, also referred to as a superuser. There are three main ways to acquire superuser power. Run one command with root user privileges with the sudo command. Sudo command means basically superuser do, an abbreviation of these words. Another way is to log in as the root user. And the third way is temporarily become the root user with the su command. Often Linux is set up for users to run the sudo commands. In fact, a password for root is not even set by default. So in most cases, to run an administrative command such as userret or some other commands which need administrative privileges, you would proceed with command by running the sudo command. For example, sudo userret-m-test user. Let's try to run it without sudo and see that we don't have any rights to do this. Let's type user-add-m-test user. And we get an error that permission is denied because we need privilege rights to run this command. So let's run it with sudo command. Let me add sudo in the beginning of this command and try to run it once more. We will need a password for this operation. Let me type my password, and that's it. The user is created with superuser privileges. Sometimes when you find that you need to run a series of commands as root user, you could type the following command to open a shell as the root user. Let's type it sudo bash or sudo-s. So let's type first sudo bash. So now we are using the shell as root user. To exit this mode, we just can type exit. And let's type now sudo-s. So it does pretty much the same. If you decide that you want to add a password for the root user that will allow you to log in as the root user and to use the su command to temporarily become root, you can also do that by the command sudo password root. Let's type it sudo passwd root. As a result, we can add the password for the root user. Now we can change the shell to the root user with su command. Let's try typing it. Su, that will change the bash command line to the user root. By the way, you could run the same command, not changing the password for root, with sudo su command. So that will do pretty much the same. The sudo command allows very granular delegation of power to the users other than the root user. The sudo facility is a great tool for granting specific escalated privileges when you have multiple users and logging everything the users do with those privileges. As I said, Linux users the sudo command to execute privileged commands rather than the su command. The sudo command is configured in etc/sudoers file. You can edit it with vsudo editor, and please note that never edit these files with your normal text editor. Instead, always use the vsudo command. This opens the Sudoers file in an editor, temporarily locks it from use by others, and does some error checking before you leave. So let's take a look at these files with sudo vsudo command. Let's type it sudo vsudo. The vsudo command launches an editor by default, the nano editor, and it looks like this. If you look at the Sudoers file that is shipped with your distribution, you'll see different empty sections delimited by commands and one active statement. Root equals all, all. This means that the user root is allowed on any hosts to run any command as any user. This file which we are looking at is at the Ubuntu Linux. Let's exit from this file and log in to the Red Hat Linux and check the same file there. So we are logging in with SSH to the Red Hat Linux edition. Let's check the version of this Linux by typing cat-etc-rel or release * to check the edition. And you see that it is a Red Hat Linux, and let's check this file again. Let's type sudo vsudo. Let's find a root string by typing /root, and to find the next instance of this string we can press N button. Let's press it again, and here it is, the line about root privileges. The same here as on Ubuntu Linux. Let's exit from this file and exit from this remote server. Ubuntu Linux adds the following: that all users are part of the admin or sudo group as set in the etc-group file. Let's open the file again. Let's type sudo vsudo to find those lines. Here they are: admin all equals all, and sudo all equals all, no password, all. So by adding some user to this line, you mean then when a user in the sudo group requests root privileges, that user gains access to that privilege without entering password. As you've noticed, I've always entered password, but you can modify that Sudoers line so a privileged user does not have to provide a password. That is not very secure, but sometimes when you are not restricted with security rules, you can add any user not to provide the password all the time for some practicing or testing purposes. When you installed your Linux, the user account you created was automatically added to the sudo group to allow additional users to acquire root privileges. You can simply add them to the sudo group, which is in the etc group file. Let's check it. Let's type cat etc group. Here we can see all the groups which are present on this operating system. Now let's do some practice. Let's create some test user and try to add him to this file. Let's create a user with user-add command. So let's type sudo user-add -m user1. Now let's create a password for this user with password passwd command user1 and enter the password for this user. Now let's change to this user shell with su command. We type su test1. Sorry, user1. Let's check which user is used with whoami command, and as you can see we are acting like user1 and it's their shell. Now let's try to run a sudo command under this user with sudo-s, and we can see that this user is not in the Sudoers file, and he or she cannot change the shell to sudo shell. Now let's exit from the shell and add this user to the Sudoers group. We can do this with any editor. Let's type sudo nano etc group. Let's find sudo group, here it is, and add this user to this group. I'll edit user 1. Let's save it by pressing Ctrl O. We will leave the same name for the file by pressing enter and Ctrl X for exiting. Now again let's change to this user by typing su user1 and try typing again sudo-s. Now this user has privileges to perform some administrative tasks which require administrative privileges, as root has. Let me exit from this user by typing exit. You also have the choice of giving a user limited root privileges instead in the etc Sudoers file. For example, you can add the following line. Let's type sudo vsudo to enter the file, and add the following line that the user1 can run less command from user bin less and can list with this last command var/log/syslog. So this allows the user to run the less command with the root privileges. Also note that this introduces a security issue, as the less command can allow this user to gain more information on the system by examining other system files. You can always check all sudo actions or all sudo attempts in the log file. It is kept in var log authentication log. That is for Ubuntu, which I am running now. Let's take a look at it. Let's type sudo cat var/log/auth/log. And we have an output of all the logs concerning sudo actions and attempts. Useful information about your shell environment is stored in what is referred to as variables. Shell variable names are all uppercase. I've already mentioned about environment variables and local variables. Let's take a closer look to variables and how to display them in alphabetical order. How to reveal all the current shell variables. To do this, we can type set and pipe it to less command. Let's type set pipe less. We can find variables concerning shell we are using. In this case it's bash shell, home directory, host name, history file, and type of our host which is used now. The set command lists local variables, environment variables, and functions as well. Opposite to shell command, set command, the env command just lists environment variables. Let's type it. Let's type env and pipe it to less as well, though it's not so long as set command. That was a little review about variables. Now let's switch to the review about permissions. Let's recall change mode command and try to review it with several exercises. Let's create a directory with make directory command. We will create a directory in our home folder and name it adir. And let's create a file with touch. Let's create a touch a file and do some activities with these two items. Let's type change mode 0700 and the name of the directory adir. Let me list this adir directory with ls command ls-la adir and check the permissions for now. The directory's owner can read and or write files in that directory as well as change it. All other users except root have no access. Now let's run change mode 0711 to the adir. Let's list it again and check the permissions. Same as for the owner, all other can change to the directory, but not view or change files in the directory. This can be useful for several situations where you prevent someone from listing directory contents but allow access to a file in the directory if someone already knows it's there. Other permissions with change mode go plus R and adir name. Let's list it again and review the permissions. It has added read permissions to a directory. Let's use change mode again. We will type change mode 0777 and the directory name adir in our case, or we could type it as change mode a equals rwx and the directory's name adir. This gives all permissions to this directory. They are wide open. Let's list the directory again. Now let's type change mode 0000 for zeros and the directory name adir. Another way of typing is change mode a minus rwx and the directory name adir. In this case, all permissions are closed. It's good to protect a directory from errant changes. So if you don't want any changes to this directory, we could use this permission. Now let's type change mode and 36666 and now we will apply it to the file, a file. Let's list the permissions for a file with ls-la and file name, in our case it's a file. These permissions open read-write permissions completely on this file. Let's perform another command, change mode go minus rwa file. Let's check the file again with list command and we can see that it doesn't let anyone except the owner to view, change or delete the file. Change mode 644 a file. And in this case, let's list it. In this case, only the owner can change or delete the file, but all can view it. Now let's review the permissions and let me append some useful information about dash capital R. Dash capital R option is a handy feature of the change mode command. With dash capital R you can recursively change permissions on all files and directories starting from a point in the file system. For example, sudo change mode dash capital R 700 for adir will open permission to owner below adir directory. Sudo change mode -r 000 adir will close all permissions below a dir directory. And sudo change mode -r a plus rwx a dir will open all permissions below a dir directory. And -R option is inclusive. It means that this option will change the permissions for the a dir itself, not only for the files and directories below this directory. Now let me add some more information about umask command. This is permissions given to a file or directory are assigned originally at the time that item is created. And how those permissions are set is based on the user's current umask value. Using the umask command, you can set the permissions given to files and directories when you create them. For example, on this table you can see how different umask commands could be used for your purposes. Like umask 0066 will make directories as follows, and umask 0077 will make directories like this. So you could use this table for your future activities concerning permissions, and this is very handy command umask. You can also change ownership for the files and directories. When you create a file or directory, your user account is assigned to that file or directory. So is your primary group. As root user, you can change the ownership of this file or directory, and group assigned to a file to a different user or group using the change own command and change group commands. So on this table you can see the example of how you can use this change own command and change group command. The recursive option to change own, that is -R, just shown, is also useful if you want or need to change the ownership of an entire directory structure. As with change mode, using change own recursively changes permissions for the directory named and along with its contents. You might use change own recursively when a person leaves a company, for example, or stops using the service. You can use change own -R capital to reassign their folder to someone else. As you remember, copying file is done with cp command. The standard cp command will copy a file to a new name or the same name in a new directory, and it will add a new timestamp to this new file. But there are a lot of different other options which can be used while copying files. One can copy file recursively and can prompt before overwriting. Now we will take a look at some examples, some more examples for copying files and directories. Let's type cp-i, then we are typing the file which will be copied. In our case it will be file1, and the destination where it will be copied to dir1. So this example shows that if file1 exists in dir1, 1 will be prompted before overwriting it with the new file. Let's press enter and see when we copy it the second time, we will see the result when we are prompted to overwrite the file. Let's rerun this command once more, and you see the result of -I option. If a file is hard linked to a file, of the same name, you could use -il for copying this file. If we want to copy all the files in the following directory, let's say we want to copy all the files which are in our home directory to dir2, for example, we can use -a option. Let's type it cp-a. Let's type full path to the directory home temp, and we will copy it to home temp dir2. This will copy all the files in the home temp to home temp dir2. Let's check it with list command. Let's ls-la home temp dir2. And keep in mind that it will also retain all ownership and permission settings. Another very useful option is -R, as you could remember. -R option, arc option also recursively copies a directory structure, but keep in mind that it assigns ownership to the current user and adds current date and timestamps. Let's rerun the previous command, but in that case we will copy all the files to the dir3. And let's check it with list command. Let's type ls-la home temp dir3. Another good way to copy data is dd command or double D command. This command is very powerful because on Linux system everything is a file, including hardware, peripherals. Let's take a look at the following command. -dev-0 is a special file that generates null characters. In this example, we can see that dd command takes dev0 as an input file and it outputs to temp my_null file, and the count is the number of blocks. By default, a block is 512 bytes. As a result, as a 512 bytes long file null of null characters. You could use less or vim to view the contents of the file. However, a better way to view the file would be the od command, and we can view this file with the following command: od-vt x1 temp my_null file. Here is another example of the dd command. Let's take a look at it. This time set the block size to 2 bytes and copy 10 blocks, that is 20 bytes. My advice to you to be very careful with this command because it can be very dangerous when you misuse this command. Improper usage of this command can wipe or destroy the data on your hard drive. Linux keeps a database of all the files in file system using features of the mlocate package. The locate command allows you to search that database. The results of the locate command come back instantly because the database is searched and not the actual file system. Before locate was available, most Linux users ran the find command to find files in the file system. Both locate and find are covered here. Because the database contains the name of many different kinds of files in the file system and not just commands, you can use locate to find commands, devices, man pages, data files, or everything else identified by a name in the file system. So let's run the command. Let's type locate and say we are looking for file.txt. Let's type it. And it instantly gives us the result. Actually, let's rerun this command and pipe it to word count-l to count how many lines did it find. So as you can see, it has found 5 lines with file.txt string or name. You can also use locate command with "-i option, this will locate all the files not case sensitive. Otherwise it is case sensitive and it is looking just for the file name you've provided. Now let's create with touch command some file with a capital letter in it. Let's say we want to create touch file.txt, but file from capital F. And now let's run the command locate-i file.txt. And it gives us the result. The mlocate package includes a cron job that runs the update db command once per day to update the locate database of files. To update the locate database immediately, you can run the update db command manually. So let's do it. Let's type sudo update db. As I've mentioned before, locate users would utilize the find command to find files. Although locate will come up with the file faster, find has many other powerful options for finding files based on attributes other than the name. Please also note that searching the entire file system can take a long time to complete. Before searching the whole file system, consider searching a subset of the file system or excluding certain directories or remotely mounted file systems. Let's try running the find command in the whole file system. And it gives us lots of results and it can take tons of time, so I'll stop it and try to find it just in my home directory. Let me change the conditions of search. Instead of root, I'll type home and temp directory. And that's much faster. You can also find files based on timestamps. The following command line finds files in my home directory with the name file.txt that have been accessed in the past 2 minutes. Let's try running it. So we use find, then the directory in which we are looking for, -home, -temp, and then -amin, -to, -print. That will find all the files with such a name which were modified in the past 2 minutes. And we don't have such files. Let's touch this file to change a timestamp of this file. Let's type touch file.txt. That will refresh the timestamp on this file, and let's try looking for this file again. And here it is. Now we can find this file. If you specify instead of amin a time parameter, that will look for the days. For example, if we specify a time plus 60, say, that will be looking for the files which have not been accessed in home-temp directory for more than 60 days. Actually, let's run this command. Let's type find home-temp /temp -a time plus, let's say, 10 days, plus 10. And it finds all the files which have not been accessed in 10 days. That's a very useful feature. Use the -type D option to find directories. The following command line finds all directories under -home-temp. If we add -perm parameter and specify the permissions like 755, this command will find all the files in our home folder with such permissions. The exec option is very powerful in find because it lets you act on the files found with the find command. The following command finds all the files in our home folder which has permission 755 and executes the ls-la command on each file. An alternative to find's exact option is xargs command. So let's rerun this command, but we will pipe it to xargs ls-la command. There are big differences on how the two commands just shown operate, leading to very different performance. The find-exact spawns the command ls for each result it finds. The xargs command works more efficiently by passing many results as input to a single ls command. To negate a search criterion, place an exclamation point before it. The next example finds all the files that are not owned by the group root and are regular files, and then does an ls-la on each. And it also redirects standard error to the bit bucket, that is def-null. So what is a user? A user account is used to provide security boundaries between different people and programs that can run commands. Usernames are just to identify them to human users and make them easier to work with. But internally, the system distinguishes user accounts by the unique identification numbers, which are assigned to users. So we've got user ID or UID. Also, this user account is a human. It will be generally assigned a secret password that this user will use to prove that they are actual authorized user when logging in. You have to understand that user accounts are fundamental to system security. Every process or running program on the system runs a particular user. Every file has a particular user as its owner. File ownership helps the system enforce access control for users of their files. The user associated with the running process determines the files and directories accessible to that process. Now, there are three main types of user account. We've got the superuser, system users, and regular users. The superuser account is for administration of the system. The name of the superuser, as you might guess, is root, and the account has UID, which is 0. The superuser has full access to the system. Okay, we've also got system user account, which are used by processes that provide support for the services. These processes or daemons usually do not need to run as superuser, and they are assigned non-privileged accounts that allow them to secure their files and other resources from each other and from regular users on the system. And these users do not interactively log in using a system user account. And there are also regular user accounts, which we use for day-to-day work, like system users, regular users have limited access to the system. Okay, we can use the ID command to show information about the currently logged in user. Let's type it. And as you see, we've got UID printed out, GID, groups, and some more information. We can also view basic information about another user by passing the username to the ID command as an argument. So let's type ID and the name of some other user. For example, user2. Now, to view the owner of a file, we can use the ls-l command, and to view the owner of a directory, we can use the ls-ld command. Let's type in some example. I'll type in ls-l and the name of the file, for example, file1. This will reveal the information about the owner of a file. Now I'll type in ls-ld dir1, and the output will be the owner of a directory, which is the third column showing the username. We can also view process information by using the ps command. The default is to show only processes in the current shell, and if you add the A option, you'll view all processes with a terminal. And you can also view the user associated with a process by including the U option. Let's type in the following command, ps-au, and the first column shows the username. So this output of the command displays users by name, but internally the operating system uses the UIDs to track users. The mapping of usernames to UIDs is defined in databases of account information, and by default systems use the /etc/password file to store information about local users, and each line in this file contains information about one user, and it is divided up into 7 colon-separated fields. So let's type in the following command, cat etc password, or I'll better type in tail etc password. So first comes user for this command output. The second column is user's password used to be stored here in encrypted format. That has been moved to the etc shadow file, which will be covered later. This field should also be X. Next is the user ID number, and you have to notice that these numbers are 1000 and above. The fourth field is group ID number for this user's account primary group, and we'll discuss groups later. Then we have real name for this user or some additional information. The sixth field is the home directory for this user. It's in /home. So it's the individual working directory when the shell starts, and it contains the user's data and configuration settings. And lastly, the default shell program for this user. It could be bin bash or bin z shell or shell or some other shell program. Also, please note that a system user might use sbin no login. It's when if interactive logins are not allowed for that user. Most operating systems have some sort of superuser, a user that has all power over the system. In Red Hat Enterprise Linux, this is the root user. This user has the power to override normal privileges on the file system and is used to manage and administer the system, to perform tasks such as installing or removing software, and to manage system files and directories. Users must escalate their privileges to the root user to do all these tasks. The root account on Linux is roughly equivalent to the local administrator account on Microsoft Windows. In Linux, most system administrators log into the system as an unprivileged user and use various tools to temporarily gain root privileges. Now, Red Hat recommends that system administrators do not log in directly as root. Instead, system administrators should log in as normal user and use other mechanisms, such as su command, sudo command, or policy kit, for example, to temporarily gain superuser privileges. So let's review the commands. We've got su command, which allows users to switch to a different user account. If you run su from a regular user account, you will be prompted for the password of the account to which you want to switch. And if you run su command from root account, you do not need to enter the user's password. So if you want to become user 1, for example, you should run the following command: su-user1. If you omit the username, the su or su- command attempts to switch to root by default. The command su starts a non-login shell, while the command su with dash option starts a login shell. The main distinction between the two commands is that su- sets up the shell environment as if it were a new login as that user, while su just starts a shell as that user, but uses the original user's environment settings. In most cases, administrators should run su- to get a shell with the target user's normal environment settings. The su command is most frequently used to get a command line interface which is running as another user, typically root. However, with the -c option, it can be used like the Windows utility run as. So you can run some command as this user. If you want to view more details on this, you can run info su to view the information on these options. Now, we can run commands with sudo command. In some cases, the root user's account may not have a valid password at all for security reasons. In this case, users cannot log in to the system as root directly with a password, and su cannot be used to get an interactive shell. One tool that can be used to get root access in this case is Sudo. Unlike su, Sudo normally requires users to enter their own password for authentication, not the password of the user account they are typing to access. That is, users who use sudo to run commands as root do not need to know the root password. Instead, they use their own passwords to authenticate access. Additionally, sudo can be configured to allow specific users to run any command as some other user, or only some commands that they can perform as that user. For example, when sudo is configured to allow the user 1 to run the command usermod as root, user 1 could run the following command to lock or unlock a user account. And he or she could type the following command: sudo usermod-l user2, provide his or her password, and the system will allow him to do this. But if a user tries to run a command as another user and the sudo configuration does not permit it, the command will be blocked. The attempt will be locked, and by default an email will be sent to the root user. And one additional benefit to using sudo is that all commands executed are locked by default to var log secure. Let me switch to root to view this log file. I'll type su, type the root's password, and then I'll type tail var log secure. Now, in Red Hat Enterprise Linux 7 and Red Hat Enterprise Linux 8, all members of the wheel group can use sudo to run commands as any user including root. The user is prompted to their own password, and this is a change from Red Hat Enterprise Linux 6 and earlier, where users who were members of the wheel group did not get this administrative access by default. So keep this in mind, that Red Hat 6 did not grant the wheel group any special privileges by default, and sites that have been using this group for a non-standard purpose might be surprised when Red Hat 7 and Red Hat 8 automatically grants all members of wheel full sudo privileges. This could lead to unauthorized users getting administrative access to Red Hat 7 and Red Hat 8 systems. Now, if there is a non-administrative user account on the system that can use sudo to run the su command, you can run sudo su from that account to get an interactive root user shell. This works because sudo will run su dash as root, and root does not need to enter a password to use su. Another way to access the root account with sudo is to use the sudo-i command. This will switch the root account and run that user's default shell, usually bash, and associated shell login scripts. If you just want to run the shell, you can use the sudo-s command. For example, an administrator might get an interactive shell as root on AWS EC2 instance by using SSH public key authentication to log in as the normal user, which is EC2-user, and then by running sudo-i to get the root user shell. The sudo su- command and sudo-i command do not behave exactly the same, and we'll discuss it briefly a bit later. Now let's configure sudo. The main configuration file for sudo is etc Sudoers. To avoid problems if multiple administrators try to edit it at the same time, it should only be edited with a special vsudo command. For example, the following line from the etc Sudoers file enables sudo access for members of group will. So let me type cat etc Sudoers. In this line, %will is the user or group to whom the rule applies. % specifies that this is a group will. The all equals all in brackets specifies that on any host that might have this file, will can run any command. The final all specifies that will can run those commands as any user on the system. By default, etc Sudoers file also includes the contents of any files in the etc sudoers.d directory as part of the configuration file. This allows an administrator to add sudo access for a user simply by putting an appropriate file in that directory. Please note that using supplementary files under the etc sudoers.d directory is convenient and simple. You can enable and or disable sudo access simply by copying a file into the directory or removing it from the directory. Further on, we'll create and remove files in the etc sudoers.d directory to configure sudo access for users and groups. Now, to enable full sudo access for the user1, you could create etc sudoers.d user1 with the following content. You could type user01 tab all equals all in brackets tab all. To enable full sudo access for the group01, you could create the following file etc sudoers.d group01 with the following content: %group01 and then followed by all equals all in brackets and all. It is also possible to set up sudo to allow a user to run commands as another user without entering their password. For example, you could add the following line: Ansible all equals all in brackets no password all. While there are obvious security risks to granting this level of access to a user or group, it is frequently used with cloud interfaces or virtual machines and provisioning systems to help configure servers. The account with this access must be carefully protected and might require SSH public key authentication in order for a user on a remote system to access it at all. For example, the official AMI for Red Hat Enterprise Linux in the Amazon Web Services Marketplace ships with the root and the EC2 user's password locked. The EC2 user account is set up to allow remote interactive access through SSH public key authentication. The user EC2 user can also run any command as root without a password, because the last line of the AMI's etc Sudoers file is set up as follows: EC2 user all equals all in brackets no password all. The requirement to enter a password for sudo can be re-enabled, or other changes may be made to tighten security as part of the process of configuring the system. Further on, you'll be frequently see sudo su dash used instead of sudo -i. Both commands work, but there are some subtle differences between them. The sudo su dash command sets up the root environment exactly like a normal login, because the su dash command ignores the settings made by sudo and sets up the environment from scratch. Whereas the default configuration of the sudo -i command actually sets up some details of the root user's environment differently than a normal login. For example, it sets the path environment variable slightly differently. This affects where the shell will look to find commands. You can make sudo -i behave more like su dash by editing etc Sudoers with vsudo. You could find the following line: default source path equals sbin, and so on, and replace it with the following two lines: defaults secure path equals /user local bin /user bin. And the second line as follows: defaults greater than root secure path equals, and the path as follows. You have to specify local sbin, local bin, and usr sbin and usr bin. For most purposes, this is not a major difference. However, for consistency of path settings on systems with the default etc Sudoers file, I'll mostly use sudo su dash. Now it's time to have a guided exercise on gaining superuser access. In this exercise, we'll practice switching to the root account and running commands as root. We'll use sudo command to switch to root, and we'll explain how su and su dash can affect the shell environment through running or not running the login scripts. Now I'll log in with my regular account and view the current user and group information and display the current working directory. I also view the environment variables that specify the user's home directory and the location of the user's executables. So I'll run id command. Next up, I'll run pwd command to display the current working directory. As you can see, it's my current user's working directory. And uid for my user and gid for my user as well. I can see the groups information for my current user. Now let's print the values of the home and path variables to determine the home directory and my user's executables path respectively. First I'll type echo $home, and after that I'll type echo $path. And these commands dump the home directory, which is home shumi, and values of the path variables for my current user. Now let's switch to root in non-login shell and explore the new shell environment. So first I'll type in sudo su without dash. at shell prompt to become the root user. Please note that I have to fill in my current user's password for the sudo prompt. Now I'll type ID to view the current user and group information. As you can see, it changed to root. Then I'll type in pwd to display the current working directory, and it hasn't changed. It is home shumi. Now let's print the values of home and pass variables to determine the home directory and user executables path, respectively. And echo $home shows us the home directory for root, and path variables have changed as well. Now, if you already have some experience with Linux and su command, you may have expected that using su without the dash option to become root would cause you to keep the current path of your current user, in my case it's shumi. And that did not happen. As you will see in the next step, this is not the usual path for root either. What happened? The difference is that you did not run su directly. Instead, you ran su as root using sudo, because you did not possess the password of the superuser. The sudo command initially overrides the path variable from the initial environment for security reasons. Any command that runs after the initial override can still update the path variable, as you will see in the following steps. So let's exit root user shell to return to the shumi user shell. I'll type in exit. Now let's switch to root in a login shell and explore the new shell environment. But this time we'll type in sudo su dash at the shell prompt to become the root user. Notice the difference in the shell prompt compared to the shell of sudo su in the preceding step. Sudo may or may not prompt for the current user's password, depending on the timeout period of sudo. That default timeout period is 5 minutes. If you have authenticated to sudo within the last 5 minutes, sudo will not prompt you for the password. If it has been more than 5 minutes since you authenticated to sudo, you need to enter your current user's password to get authenticated to sudo. Now let's run ID to view the current user and group information. And it shows root for UID and for GID root as well. And groups is also root. Now let's type in pwd to display the current working directory, and it shows the root's current directory. Again, let's print the values of the home and path variables to determine the home directory and the user's executables path, respectively. I'll type in echo $home, and it shows the home for root, and I'll type in echo $path. And as in the preceding step, after sudo reset the path variable from the settings in the shumi user's home environment. The su dash command ran the shell login scripts for root and set the path variable to yet another value. The su command without the dash did not do that. So for now, I'll exit the root user shell to return to the shumi's user shell. Now let's create a new user to have some demonstration steps using sudo command. So I'll type sudo user add operator1. This will create a new user with the name operator1 with all the defaults. Now I'll add password for operator1 by typing passwd operator1, and I have to type in the password for operator1 user. I'll use some simple password like 123, and I'll get some warnings that the password is not that secure, but that's okay for demonstration purposes. I have to repeat this step again, and now we can use this user. But before we go to the next steps, let's add operator1 to Sudoers. For this, I'll have to change my directory to etc sudoers.d directory and create a file for operator 1 by typing vim operator 1 and add the following line: operator 1 space all equals all in parentheses space all. This will allow to perform operator 1 user any action and any command on this system. So to save this file, I'll type :wq. And now we have to check if operator 1 user is configured as to run any command as any user using sudo. So I type sudo cat /etc/sudoers.d/operator1. Now let's become operator 1 and view the contents of var log messages, and to copy etc mod d to etc mod d alt and remove it, I mean the newly copied file, which is etc mod d alt. So these operations will require administrative rights, and we have to use sudo to run those commands as the superuser. But we won't switch to root using sudo su or sudo su dash commands. So let's switch to operator 1 by typing su dash operator 1. I'll type in the password for operator 1, and now let's attempt to view the last 5 lines of /var/log/messages without using sudo. As you might guess, this should fail. So I type tail-5 var log messages, and it gives me an error, permission denied. Now let's attempt to view the last 5 lines of var log messages with sudo command, and this should succeed. I'll type in sudo tail-5 var log messages. Now let's perform another action. Let's attempt to make a copy of etc/mod d as etc mod d alt without using sudo, and this should fail, as you might guess. I'll type cp etc mod d followed by etc mod d alt, and it gives me a message: cannot create regular file etc mod d alt, permission denied. And if we perform this action with sudo command, this should succeed. So I'll press up arrow and add sudo command in the beginning of the previous one-liner. Again, let's attempt to delete etc mod d alt without using sudo, and this should fail as well. So I type rm etc mod d alt, and it gives me an error, permission denied. And when we attempted to do it with a sudo command, this will succeed. So I'll press up arrow again and type sudo in the beginning of the previous one-liner, and this will succeed. Now let's exit the operator 1 user shell to return to the shume user shell. I'll type exit. We've already added a new user with user add command. Let's continue looking at this command and add some more users. So user add plus username command creates a new user named whatever name you have. It sets up the user's home directory and account information and creates a private group for the user named, for example, user3. At this point, the account does not have any valid password set, and the user cannot log into the system until a password is set. Of course, you can read help files by typing in user-add --help command, and this will display the basic options that can be used to override the defaults. In most cases, the same option can be used with the user-mod command to modify an existing user. Some defaults, such as the range of valid UID numbers and default password agent rules, are read from the etc.login.devs file. Values in this file are only used when creating new users. A change to this file does not affect existing users. As you might guess, user-mod command modify existing users from the command line. And of course you can read the basic options with user-mod --help command. Some common options include -c or -- command, followed by the command itself. This option will add the user's real name to the command field, or any other command you'd like to add. You could use also option -g or --gid, followed by the group name. This will specify the priority group for the user account. -G or --groups, followed by groups, will specify a comma-separated list of supplementary groups for the user account. We've got also -a option, which will be used with the -G option to add the supplementary groups to the user's current set of groups memberships, instead of replacing the set of supplementary groups with a new set. Also, there is a -d or --home followed by home directory option, which will specify a particular home directory for the user account. -m or --move home will move the user's home directory to a new location, and it must be used with the -d option. There is also a -s option, which will specify a particular login shell for the user account. Or the long option is --shell, and of course it is followed by the shell you want to use. And we've got -L or --log option, which will log the user account, and -U or --unlock. This will unlock the user's account. As opposite to adding users, we can delete users. So the command is userdel followed by the username. This command will remove the details of username from etc password file, but it will leave the user's home directory intact. If you want to remove the details of user from etc password and also delete the user's home directory, you have to use userdel -r option followed by the username. Please note that when a user is removed with userdel without the -r option specified, the system will have files that are owned by an unassigned UID. This can also happen when a file having a deleted user as its owner exists outside the user's home directory. This situation can lead to information leakage and other security issues. Also, please note that in Red Hat Enterprise Linux 7 and Enterprise Linux 8, the user-add command assigns new users the first free UID, which is greater than or equal to 1000, unless you explicitly specify one using the -u option. And this is how information leakage can occur. If the first free UID had been previously assigned to a user account which has since been removed from the system, the old user's UID will get reassigned to the new user, given the new user ownership of the old user's remaining files. So it's better to delete user with -r option, or plan the delete of the user taking into account this information. Take a look at such a situation. Let's add user. We'll type in user-add, user3. Now let's type ls-l/home to see the user's 3 files. Now let's delete this user by typing in userdel user3, again ls-l home, and now let's add a new user with user-add command user4, and again type in ls-l/home. And as you can see, the files which belonged to user 3 now belong to user 4. Depending on the situation, one solution to this problem is to remove all unowned files from the system when the user that created them is deleted. Another solution is to manually assign the unowned files to a different user. The root user can use the find /-no user -o-no group command to find all unknown files and directories. Now, let's talk about setting passwords from the command line. The password followed by username command sets the initial password or changes the existing password of username. The root user can set a password to any value. A message is displayed if the password does not meet the minimum recommended criteria, but is followed by a prompt to retype the new password and all tokens are updated successfully. So let's create a new user who will be user 5 and we'll type in user@ user5 followed by the command passwd user5 and create a password for user 5. I'll type in 123. It will give me a warning that it's a bad password, but I'll retype the password and it will give me an informational message that all authentication tokens updated successfully. Please note that a regular user must choose a password at least 8 characters long and is also not based on a dictionary word, the username or the previous password. Now some words about UID ranges. As you remember, specific UID numbers and ranges of numbers are used for specific purposes by Red Hat Enterprise Linux. We've got UID 0, which is always assigned to the Superuser account, which is root. Then we've got UID 1 to 200. It's a range of system users assigned statically to system processes by Red Hat. Then we've got UID range from 201 to 999. It's a range of system users which is used by system processes that do not own files on the file system. They are typically assigned dynamically from the available pool when the software that needs them is installed. Programs run as these unprivileged system users in order to limit their access to only the resources they need to function. And then we've got UID 1000 plus. This range is available for assignment to regular users. Please note that prior to Red Hat Enterprise Linux 7, the convention was that UID 1 from 1 to 499 was used for system users and UID from 500 plus was used for regular users. And of course, default range used by user-add and group-add can be changed in the etc login.devs file. We continue to work with user accounts, and in this practical exercise we'll create several users and then modify these user settings. First I'll switch to su to root accounts by typing in sudo su- and add some operators to this system. I'll type user-add operator 2. This will create a user account operator 2, and to check this, I'll type in tail etc password. And we can find the line for operator 2 with their UID, GID, home directory, and so on. Now let's set the password for this user. I'll type passwd operator 2, type in their password, repeat it, and on this point, operator 2 can log into the system and use it. Now I'll create operator 3 by typing in user add operator 3, then create their password by typing in password operator 3, and repeat this step for operator 4. We'll need these user accounts for our further practice exercises, where we'll be modifying the settings for these users and adding them to groups and so on. Now let's modify operator 2 user account by typing in usermod-c, and the command for this user account in double quotes, I'll type in operator 2 here, close the quotes, and add the user's name, which is operator 2. I'll do so for operator 3 user account as well. So I'll press up arrow and modify the command for operator 3 and the user's name itself. Now let's check these accounts by typing tail etc password. And as you can see, these accounts are in place with the commands describing the accounts. Now let's delete operator 4 account by typing in userdel-r operator 4. And again check that the line for this account disappeared in etc password. We'll type tail etc password. And as you can see, we haven't got a line for operator 4 user account. And this will finish this practice exercise where we've added, modified, and deleted user accounts. After creating some users on our system, let's move on and create, modify, and delete local group accounts. You have to know that group must exist before a user can be added to the group. And we've got several command line tools to manage local group accounts. The first one is group add command, which creates groups. Without options, the group add command uses the next available GID from the range specified in the etclogin.devs file while creating the groups. The -g option specifies a particular GID for the group to use. So let's go ahead and create a new group, which will be called group 01. I'll type in sudo group add-g, give it a GID 10,000, and give it a name group 01. Next up, I'll check that the group is created by typing in tail etc group. And as you can see, we've got a line for group 1 with GID 10,000. Please note that given the automatic creation of user private groups, which as you remember is GID 1000 plus, it is generally recommended to set aside a range of GIDs to be used for supplementary groups. A higher range, as in my example, will avoid a collision with the system group. So we've created a group with GID 10,000. Now the -r option creates a system group using a GID from the range of valid system GIDs listed in the etclogin.devs file, and the sys_gid_main and sys_gid_max configuration items in this file define the range of system GIDs. So let's create a new group by typing in sudo group add-r group 02, and let's check which GID was set to this group by typing tail etc group. And as you can see, group 02 has got this GID automatically. Now we can modify existing groups from the command line. Of course, the group mod command changes the properties of an existing group. The -n option specifies a new name for the group. So let's try. sudo group mod -n, and we'll give a name to group, a new name to group 02, which will be group 0022, followed by the old name, which is group 02. Let's check it by typing tail etc group. And we've got a new group, a new name for the old group, and please note that GID is the same, just the name was reset. Also, we've got -g option, which specifies a new GID. So let's try this option. We'll type sudo group mod -g 20,000 group 0022. This will give a new GID, and we can check it by typing tail etc group, and as you can see it is changed to 20,000. And of course we can delete the groups by using group del command, which will remove necessary groups. Let's try it by typing sudo group del group 0022. Please note here that you cannot remove a group if it is the primary group of any existing user. As with user del, check all the file systems to ensure that no files remain on the system that are owned by the group. Now, we can change group memberships as well. The membership of a group is controlled with the user management, and we can use the user mod -g command to change a user's primary group. Let's check the primary group for user 02. I'll type ID user 02. And now let's try to change it by typing sudo user mod -g group 01 user 02. And again, let's check the user 02 by typing ID user 02. And as you can see, the group membership for this user is changed. Now, you can use the user mod -a command to add a user to a supplementary group. Let's check user 3. I'll type ID user 03. And now let's add some groups to this user. I'll type sudo user mod -a group 01 user 03. And check the user again with ID command by typing ID user 03. And now you can see that this user belongs to several groups. He's got his primary group and supplementary group. It's important to remember that the use of the -a option makes user mod function in append mode. Without -a, the user will be removed from any of their current supplementary groups that are not included in the -G options list. We continue practicing exercises with managing local group accounts. And let's start with creating the operator's supplementary group with the GID of 30,000. We'll type group add -g 30,000 operators. Now let's create admin as an additional supplementary group. We'll type group add admin and verify that both operators and admin supplementary groups exist. So we'll type tail etc group, and as you can see we've got operators group and admin group. Now let's ensure that the user operator 1, operator 2 and 3 belong to the group operators. We'll add these 3 users to operators group by typing user mod -a G operators operator 1. This will add operator 1 to the group operators, and we'll repeat these steps for the user operator 2 and operator 3 by pressing up arrow on keyboard and changing operator 1 to 2 and 3. Now let's confirm that the users are successfully added to the group. We'll type ID operator 1, then we'll repeat the step with ID operators 2 and operator 3. And as you can see, all 3 users are added to the operators group is GID 30,000. Now I've got 3 sysadmin users on this system. I've pre-created them before. Now let's ensure that the users sysadmin 1, sysadmin 2, and 3 belong to the group admin and will enable administrative rights for all the group members of admin. And then we'll verify that any member of admin can run administrative commands. So we'll first add sysadmin 1, sysadmin 2, and 3 to admin group by typing usermod -A admin sysadmin 1. And we'll repeat this step for sysadmin 2 and for sysadmin 3. Now let's confirm that the users are successfully added to the group by typing ID sysadmin 1. And as you can see, this user account belongs to the admin group. And we can also examine the etc group file to verify that the supplemental group membership is in place. We'll type tail etc group, and as you can see, we've got operators group here and admin group here with its GID and members in place. Now we have to create the admin file in etc sudoers.d directory to ensure that the members of admin have full administrative privileges. I'll type echo quotes %, admin, %, as you remember, it's a sign of that it's a group, followed by all equals all in parentheses, and followed by all, quotation close, and we'll redirect it to the file etc sudoers.d admin. This will append this line to this file. Now let's try to switch to sysadmin 1, a member of admin group, and verify that we can run a sudo command as sysadmin 1. We'll type su-sysadmin 1, and now we'll try to perform the sudo command by typing sudo cat etc sudoers.d admin. We'll type a password for this user account. In my case, it's a very simple password. And as you can see, this particular user has privileged rights to perform any commands on this system. I'll exit sysadmin 1 user's shell to return to my root user shell. Now, when we had some practice with user accounts and groups, let's take a look at some exercises with managing user passwords. At one time, encrypted passwords were stored in the password file, which you know is etc password. This was thought to be reasonably secure until dictionary attacks on encrypted passwords became common. At that point, the encrypted passwords were moved to a separate etc shadow file, which is readable only by root. This is a new file also allowed password aging and expiration features to be implemented. Like etc password, each user has a line in the etc shadow file. A simple line from etc shadow could be fetched from this file. So let's type tail etc password, and remember to use privileged account for this operation. So in this line we have a username of the account this password belongs to. Next, we have encrypted password of the user. The format of encrypted passwords is discussed later in this video. Then we have the day on which the password was last changed. This is set in days since 1970, the 1st of January, and is calculated in the UTC time zone. Then we have minimum number of days that have to elapse since the last password change before the user can change it again. After that, we have the maximum number of days that can pass without a password change before a password expires. An empty field means it does not expire based on time since the last change. The next field is warning period. The user will be warned about an expiring password when they log in for this number of days before the deadline. Next up is inactivity period. Once the password has expired, it will still be accepted for login for this many days. After this period has elapsed, the password will be locked. Next up, the day on which the password expires. This is set in days since 1970, the 1st of January, and calculated in the UTC time zone. An empty field means it does not expire on a particular date. And the last field is it is usually empty and reserved for future use. Now let's take a closer look to the format of encrypted password. The encrypted password field stores three pieces of information: the hashing algorithm used, the salt, and the encrypted hash. Each piece of information is delimited by the $sign. So here we have the first field, which is the hashing algorithm used for this password. The number 6 indicates it is a SHA-512 hash, which is the default in Red Hat Enterprise Linux 8. A 1 would indicate MD5, a 5 SHA-256 algorithm. Then we have the next field, which is the salt used to encrypt the password. This is originally chosen at random. And the last field is the encrypted hash of the user's password. The salt and the encrypted password are combined and encrypted to generate the encrypted hash of the password. Now, the use of the salt prevents two users with the same password from having identical entries in the etc shadow file. For example, even if user 01 and user 02 both use 123 as their passwords, their encrypted passwords in etc shadow will be different if their salts are different. Now some words about password verification. When a user tries to log in, the system looks up the entry for the user in etc shadow, combines the salt for the user with the unencrypted password that was typed in, and encrypts them using the hashing algorithm specified. If the result matches the encrypted hash, the user typed in the right password. If the result does not match the unencrypted hash, the user typed in the wrong password and the login attempt fails. This method allows the system to determine if the user typed in the correct password without storing that password in a form usable for logging in. Now let's take a look at configuring password agent. The following diagram relates the relevant password agent parameters, which can be adjusted using the change command to implement a password agent policy. As you might guess, CH is an abbreviation for change age. So let's take a look at the following command. I'll type in sudo ch-m0-m capital 90 -w capital 7 -i capital 14 and user 03. This ch command uses the -m -capital M -capital W and -capital I options to set the minimum, maximum age, warning period and inactivity period of the user's passport respectively. The ch-d0 for user 03 forces the user 03 to update its password on the next login. Then when we type in ch-l user 03, this command will display the password agent details for this user. So let's type in ch-l user 03. Now if we type in ch-E, let's say 2020 1010, and followed by user 03. This command causes the user 03 account to expire on the 10th of October, year 2020. Here we have the following format. First goes year, then month, and then the day. Please note that we can use the date command to calculate a date in the future, and the -u option reports the time in UTC. For example, we could enter the following command, date-d in quotes plus 45 days followed by -u option. Now we can edit the password agent configuration items in etc login.devs file to set the default password agent policies. Here we have passmax days, which will set the default maximum age of the password, and passmin days, which will set the default minimum age of the password. The passwarn age will set the default warning period of the password. Any change in the default password agent policies will be effective for new users only. The existing users will continue to use the old password agent settings rather than the new ones. Now we can also restrict access. You can use the change command to set account expiration dates. When that date is reached, the user cannot log in to the system interactively. The user mod command can lock an account with the -L option. So let's try these commands. We'll type in sudo user mod -L user3. Now let's try to log in with this user's account. I'll type in su-user03. Type in their password, which is 123 for me, and I'll get authentication failure. If a user leaves the company, the administrator may lock and expire an account with a single user mod command. The date must be given as the number of days since, again, 1970, 1st of January, or in the year, month, day format. So let's try the following command. Sudo user mod -L -e 2020-11-11 user03. This user mod command uses the -e option to set the account expiry date for the given user account. The -L option locks the user's password. Locking the user's account prevents the user from authenticating with a password to the system. It is the recommended method of preventing access to an account by an employee who has left the company. If the employee returns, the account can be unlocked with user mod -U. And if the account was also expired, be sure to also change the expiration date. And lastly, some words about no-login shell. The no-login shell acts as a replacement shell for the user accounts not intended to interactively log into the system. It is wise from the security standpoint to disable the user account from logging into the system when the user account serves a responsibility that does not require the user to log into the system. For example, a mail server may require an account to store mail and a password for the user to authenticate with the mail client used to retrieve mail. That user does not need to log directly into the system. A common solution to the situation is to set the user's login shell to as being no login, and if the user attempts to log in to the system directly, the no login shell closes the connection. So let's try the following command. User mod -s has been no login user03. Now let's try to change to this user. I'll type su-user03 and we'll get an informational message that this account is currently not available. Please note that this no login shell prevents interactive use of the system, but it does not prevent all access. Users might be able to authenticate and upload or retrieve files through applications such as web applications, or file transfer programs or mail readers, if they use the user's password for authentication. Let's continue with practicing managing user passwords, and in this practice exercise we'll force a password change with the user logs in the system for the first time. Then we'll force a password change every 90 days and set the account to expire 180 days from the current day. Let's start with the following command: sudo usermod -A operator 1. This will lock user account operator 1, and remember to use administrative rights with this command. Now let's attempt to log in as operator 1, and this should fail. I'll type in su-operator 1, put in his password, and I'll get authentication failure. Now let's unlock the operator 1 account with sudo usermod -U operator 1, and again attempt to log in as operator 1. This should succeed. I'll type in su-operator 1, his password, and I'll log in. I'll exit out of the operator 1 user's shell to return to the Shumi user shell. I'll type exit. Now let's change the password policy for operator 1 to require a new password every 90 days. And let's confirm that the password age is successfully set. So first I'll set the maximum age of the operator 1 user's password by typing in sudo ch-M 90 operator 1. And now I'll verify that operator 1 user's password expires 90 days after it is changed. So I type sudo ch-L operator 1. And as you can see, this line maximum number of days between password change is set to 90. Now let's force a password change on the first login for operator 1 account. I'll type sudo ch-D 0 operator 1. And I'll try to log in as operator 1 and change the password for this user's account. And remember that it should be a long secure password, because you cannot set unsecure password if you are not root. So I'll log in as operator 1 by typing su-operator 1 and his old password, which is 123, and I'll be required to change the password immediately. So I'll type in some secure password here, I'll repeat it again, and that will be done. Now I'll exit and set the operator 1 account to expire 180 days from the current day. Again, we can use date-d command, which will give you the exact day and time 180 days from the current date. We'll also use %F with the date command to get exact value. So I'll type in date-d quotes plus 180 days followed by plus %F. And I can use this exact format of the date to set the following setting. I'll type in sudo ch-E, the date I've got in the previous command, followed by the username operator 1. Now let's verify that the account expire date is successfully set by typing sudo ch-L operator 1. And as you can see, we've got this account expires line set to the exact day we wanted. Now let's set the password to expire 180 days from the current date for all users. We have to use administrative rights to edit this configuration file. So we have to change the setting pass_max_days to 180. And the file, as you might remember, is etc/login.devs. So I'll use vim editor to change this setting. I'll type sudo vim etc/login-devs, and I have to find this line by using slash and begin to type the line I want to find, which is pass_max_days. And when I found this line, I have to put my cursor on the spot I want to change and use I or A command to change this setting. As you might remember, I is for insert. This will add the change after the cursor, and A is for append. This will add the text before the cursor. I'll type in 180, then I'll press escape, type the following command :wq, which means write quit, and this will change the setting for all the users on the system. Please remember that this change is just for new users. It won't be effective for existing users. And this will end this practice exercise. I'll type exit to return to my current user shell. Congratulations, it's time for you to complete the lab on managing local users and groups. Here you'll have 7 tasks which you'll have to complete. So the first task is that you have to ensure that the newly created users have passwords that must be changed every 30 days. Task number 2, you have to create the new group called consultants with a JIT of 40,000. Task number 3, you have to configure administrative rights for all members of consultants to be able to execute any command as any user. Task number 4, you have to create the consultant 1, consultant 2, and consultant 3 users with consultants as their supplementary groups. Task number 5, you have to set the consultant 1, 2, and 3 accounts to expire in 90 days from the current day. Task number 6, you have to change the password policy for the consultant 2 account to require a new password every 15 days. And task number 7, you have to force the consultant 1, 2, and 3 users to change their passwords on their first login. And of course, if you have some troubles to complete these tasks, you can refer to the next video that goes after you unpress pause here and see how to perform each of these tasks. Of course, you have to try to solve all these tasks by yourself, because it will be much more use if you perform this entirely by yourself. So let's continue. I hope you've solved all the tasks, but if you have some questions, here come the solutions for each of these tasks. Task number 1, you have to change the passwords that must be changed every 13 days. So you had to set pass max days to 30 in etc/login.devs file using administrative rights while opening this file. You could perform this by opening it in vim editor, typing sudo vim etc/login.devs, finding the necessary line, which is pass_max_days. You had to set your cursor on the appropriate position and press either I or A command to change the number. And set the number to 30, then press escape, type :wq. The next task, you had to create the new group consultants with a GID of 40,000. The command to perform was to type sudo group add-g 40,000 consultants. Now let's configure administrative rights for all members of consultants to be able to execute any command as any user. So we had to create the new file in etc sudoers.d directory with the name consultants and add the following content to it. %consultants all equals all in parentheses and followed by all. So let's open the file by typing sudo vim etc sudoers.d/consultants, type the command %consultants all equals all in parentheses and followed by all. Save the file by typing :wq, and now we can create 3 consultants, consultant 1, 2, and 3 by typing the following command: sudo user-G consultants, it's the group, the supplementary group, and the name of the account, which is consultant 1, then repeat the previous command consultant 2 and consultant 3. Now let's set the consultant 1, 2, and 3 user accounts to expire in 90 days from the current date. Let's determine the date 90 days in the future by typing the following command: date-d in quotes plus 90 days followed by plus %F, and use this output for the next command. We'll type sudo change-E, the date you've got in the previous command, consultant 1, and repeat the steps for consultant 2 and 3. Now let's change the password policy for the consultant 2 account to require a new password every 15 days. So you have to type the following command: sudo change-M 15 consultant 2. Additionally, let's force the consultant 1, 2, and 3 users to change their passwords on the first login. So we have to set the last day of the password change to 0, so that the users are forced to change the password whenever they log in to the system for the first time. And the command looks like this: sudo change-d 0 consultant 1, and repeat the steps for consultant 2 and 3. This will finish the lab on managing local users and groups. I hope it was informative and that you'll use this information in your future professional life. In this section, we'll be talking about Linux file system permissions, and we'll have several practice exercises related to this topic. To remind you, file permissions control access to files. The Linux file permission system is simple but flexible, which makes it easy to understand and apply, yet still able to handle most normal permissions cases easily. Files have 3 categories of user to which permissions apply. The file is owned by a user, normally the one who created the file. The file is also owned by a single group, usually the primary group of the user who created the file. But this can be changed. Different permissions can be set for the owning user, the owning group, and for all other users on the system that are not the user or a member of the owning group. The most specific permissions take precedence. User permissions override group permissions, which override other permissions. We have 3 categories of permissions: read, write, and execute. Please note that users normally have both read and execute permissions on read-only directories, so that they can list the directory and have full read-only access to its contents. If a user only has read access on a directory, the names of the file in it can be listed, but no other information, including permissions or timestamps, are available, nor can they be accessed. If a user only has execute access on a directory, they cannot list the names of the files in the directory. But if they already know the name of a file. They can access the contents of that file by explicitly specifying the file name. A file may be removed by anyone who has write permission on the directory in which the file resides, regardless of the ownership or permissions on the file itself. This can be overridden with a special permission. The sticky bit. We'll discuss it later in this video or in next video. You have to know that Linux file permissions work differently than the permissions system used by the NTFS file system on Windows, Microsoft Windows. On Linux, permissions apply only to the file or directory on which they are set. That is, permissions on a directory are not inherited automatically by the subdirectories and files within it. However, permissions on a directory can block access to the contents of the directory depending on how restrictive they are. The read permission on a directory in Linux is roughly equivalent to list folder contents in Windows. The write permission on a directory in Linux is equivalent to modify in Windows. It implies the ability to delete files and subdirectories. In Linux, if write and the sticky bit are both set on a directory, then only the user that owns a file or subdirectory in the directory may delete it, which is close to the behavior of the Windows write permission. The root user on Linux has the equivalent of the Windows full control permission on all files. However, root may still have access restricted by the system's SE Linux policy and the security context of the process and files in question. SE Linux will be discussed later on in this course. Now, of course, you remember that the -L option of the ls command shows more detailed information about file permissions and ownership. So if we type ls-l test, we'll get the detailed information on that file. You can use the -d option to show detailed information about a directory itself and not its contents. So let's type ls-ld/home. Let's recall this information about the first character of the long listing of ls command. You interpret it like this. Dash is a regular file. D here is a directory. And L is a soft link. There are also other characters which represent hardware devices like B and C, or other special purpose files like P and S. Then we have the next 9 characters, which are the file permissions. These are in 3 sets of 3 characters. Permissions that apply to the user that owns the file, the group that owns the file, and all other users. If the set shows RWX, that category has all 3 permissions: read, write, and execute. If a letter has been replaced by dash, then the category does not have that permission. After the link count, the first name specifies the user that owns the file, and the second name the group that owns the file. So, in the example above, the permissions for user Shumi are specified by the first set of 3 characters. The user has read and write on test, but not execute. Group Shumi is specified by the second set of 3 characters. It also has read and write on test, but not execute. And any other user's permissions are specified by the third set of 3 characters. They only have read permission on this test file. The most specific set of permissions apply. So if user Shumi has different permissions than group Shumi, and user Shumi is also a member of that group, then the user permissions will be the ones that apply. Let's take a look at the following example which will help illustrate how file permissions interact. For these examples, we have 4 users with the following group membership. Those users will be working with files in the dir directory, and this is a long listing of the files in that directory. And of course, you have to remember that -A option shows the permissions of hidden files, including the special files used to represent the directory and its parent. In this example, dot reflects the permissions of dir itself, and double dot the permissions of its parent directory. So what are the permissions of rfile1? The user that owns the file, which is database1, has read and write but not execute. The group that owns the file consultant1 has read and write but not execute. All other users have read but not write or execute. So let's take a closer look at the permissions in that example. Here, user operator 1 is a member of the consultant1 group, and that group has both read and write permissions on rfile1. So the user operator 1 can change the contents of rfile1. Next up, the user database 1 owns the file and has both read and write access to rfile2. So the user database 1 can view and modify the contents of rfile2. Next up, user operator 1 is a member of the consultant1 group, and that group only has read access to rfile2. So the user operator 1 can view but not modify the contents of rfile2 without deleting it and recreating it. Next up is other. Other permissions apply to users database 2 and contractor 1, and those permissions do not include read or write permissions. So the user database 2 and contractor 1 do not have any access to the contents of rfile2. Next up, user and group operator 1 have write permissions of the file. Other users do not, but the only member of group operator 1 is user operator 1. So operator 1 is the only user who can change the contents of lfile1 without deleting it and recreating it. Next up, the user database 2. He is not the user that owns the file and is not in group consultant 1. So other permissions apply on this user. Those grant write permission. So the user database 2 can change the contents of lfile2. Next up, the user database 1. He is a member of the group consultant 1, and that group only has read permissions on lfile2. Even though other has write permission, the group permissions take precedence. So the user database 1 can view the contents of lfile2 but cannot modify the contents of lfile2. And finally, the user database 1 has write permission on the directory containing both files, shown by dot, and therefore can delete any file in that directory. This is true even if database 1 does not have write permission on the file itself. So the user database 1 can delete lfile1 and lfile2. The command used to change permissions from the command line is chmod, which means change mode. Permissions are also called the mode of a file. The change mode command takes a permission instruction followed by a list of files or directories to change. The permission instruction can be issued either symbolically, it's a symbolic method, or numerically, it's a numeric method. Now, let's first review changing permissions with the symbolic method. The structure of the command looks as follows. You type the command itself, change mode, then followed by who what and which file or directory. By who you mean user, group, other, and all. By what you mean what to do with the permissions, to add, remove, or set exactly. And by which you mean to read, write, and execute permissions. The symbolic method of changing file permissions uses letters to represent the different groups of permissions. And the letters are as follows. U you use for user, G you use for group, O you use for other, and A for all. With the symbolic method, it's not necessary to set a complete new group of permissions. Instead, you can just change one or more of the existing permissions. And you use plus or minus to add or remove permissions respectively. Or you use equal sign to replace the entire set of a group of permissions. Now, the permissions themselves are represented by a single letter R for read, W for write, and X for execute. When using change mode to change permissions with the symbolic method, using a capital X as the permission flag will add execute permission only if the file is a directory or already has execute set for user, group, or other. Now, change mode command supports the -R capital option to recursively set permissions on the files in an entire directory tree. When using the -R capital option, it can be useful to set permissions symbolically using the capital X option. This allows to execute search permission to be set on directories so that their contents can be accessed without changing permissions on most files. But be cautious with the capital X option, because if a file has any execute permission set, capital X will set the specified execute permission on that file as well. For example, the following command recursively sets read and write access on demo.dir and all its children for their group owner, but only applies group execute permissions to directories and files that already have execute set for user, group, or other. And the command looks like this: change mode -R capital G plus RW capital X demo.dir. Now let's review another example which will remove read and write permission for group and other on file 1. And the command looks like follows: change mode go -RW file 1. And another example, to add execute permission for everyone on file 2, we type change mode A plus X file 2. Another method to change permissions is the numeric method. In this example below, the hashes characters represent a digit and followed by file or directory to change. Now, each digit represents permissions on an access level. It's user, group, or other. The digit is calculated by adding together numbers for each permission you want to add. 4 for read, 2 for write, and 1 for execute. Using the numeric method, permissions are represented by a 3-digit or 4-digit when setting advanced permissions, and form octal number. A single octal digit can represent any single value from 0 to 7. In the 3-digit octal representation or numeric representation of permissions, each digit stands for one access level, from left to right, and goes as follows: user, group, and other. And to determine each digit, we have to follow 4 steps. Start with 0. If the read permission should be present on this access level, add 4. If the write permission should be present, add 2. and if execute permission should be present, add 1. So let's examine these permissions. -rwx, r-x, and 3 dashes. For the user here we have rwx, and it is calculated as 4 plus 2 plus 1, and it will be 7. For the group here we have r-x, and we calculate it as follows: 4 plus 0 for dash and plus 1 for x, and it's calculated as 5. And for other users we have 3 dashes, which is represented with 0. Putting these 3 together, the numeric representation of those permissions is 750. This calculation can also be performed in the opposite direction. Look at the permissions 640. For the user permission, 6 represents read, 4 and write 2, which displays as rw dash. For the group part we have 4, and it's read, and it will be displayed as r dash dash. And the 0 part for other provides no permission, and will be displayed as 3 dashes. Experienced administrators often use numeric permissions because they are shorter to type and pronounce, while still giving full control over all permissions. Let's review some examples. Let's set read and write permissions for user, read permission for group, and other on sample file. And we'll type the following command: change mode 644 sample file. Another example, let's set read, write, and execute permissions for user, read and execute permissions for group, and no permission for other on sample dir. And we'll type the following command: change mode 750 sample dir. A newly created file is owned by the user who creates that file. By default, new files have a group ownership, that is a primary group of the user creating the file. In Red Hat Enterprise Linux, a user's primary group is usually a private group with only that user as a member. To grant access to a file based on group membership, the group that owns the file may need to be changed. Now, only root can change the user that owns a file. Group ownership, however, can be set by root or by the file's owner. Root can grant file ownership to any group, but regular users can make a group the owner of a file only if they are a member of that group. So, file ownership can be changed with the change owner command. For example, to grant ownership to the test file to the student user, we'll use the following command: chown student test underscore file. Chown can be used with the -R option to recursively change the ownership of an entire directory tree. Let's review the following command, which grants ownership of test underscore dir and all files and subdirectories within it to student. We'll type chown -R student test underscore dir. Chown command can also be used to change group ownership of a file by preceding the group name with a colon. For example, the following command changes the group test underscore dir to admins. We'll type chown space colon admins and the name of the directory. In our case, it's test underscore dir. The chown command can also be used to change both owner and group at the same time by using the owner:group syntax. For example, to change the ownership of a test_dir to visitor and the group to guests, we'll use the following command: chown visitor guests test_dir. Sometimes instead of using chown command, some users change the group ownership by using the chgrp command or change group command. This command works just like chown or change ownership, except that it is only used to change group ownership and the colon before the group name is not required. Now pay attention that you might encounter examples of chown commands using an alternative syntax that separates owner and group with a period instead of a colon. And the command looks like this: chown owner.group and the file name. You should not use this syntax. Always use a colon. A period is a valid character in a username, but a colon is not. If the user enoch.root, the user enoch and the group root exist on the system, the result of chown enoch.root file name will be to have file name owned by the user enoch.root. You may have been trying to set the file ownership to the other enoch and group root, and this can be confusing, so always try to use colon. And if you always use the chown colon syntax when setting the user and group at the same time, the results are always easy to predict. In this guided exercise, we'll use file system permissions to create a directory in which all members of a particular group can add and delete files. As a result, you should be able to create a collaborative directory that is accessible by all members of a particular group. So I'll log into my workstation and switch to the root user, and use the mkdir command to create the home consultants directory. So I'll type mkdir/home/consultants. Then I'll use the chown command to change the group ownership of the consultants directory to consultants. So I'll type chown consultants/home/consultants. Now I'll ensure that the permissions of the group allow group members to create and delete files. The permission should forbid others from accessing the files. So I'll use the ls command to confirm that the permissions of the group allow group members to create and delete files in the /home/consultants directory. I'll type ls-ld home consultants. And please note that the consultants group currently does not have write permissions. So next up, I'll use the chmod command to add write permissions to the consultants group. I'll type chmod g+w home consultants, and then I'll type ls-ld home consultants. Please note that now consultants group have write permissions. Next up, I'll use the chmod command to forbid others from accessing files in the home consultants directory. I'll type chmod 770 home consultants and check again. I'll type ls-ld home consultants. Now I'll exit the root shell and switch to the consultant1 user with his password and navigate to the home consultants directory and create a file called consultant1.txt. So I'll use the cd command to change to the home consultants directory by typing cd home consultants, and then I'll use the touch command to create an empty file called consultant1.txt. I'll type touch consultant1.txt. Now I'll use the ls-l command to list the default user and group ownership of the new file and its permissions. So I'll type ls-l consultant1.txt. Next up, I'll ensure that all members of the consultants group can edit the consultant1.txt file, and I'll change the group ownership of the consultant1.txt file to consultants. So I'll use the change own command to change the group ownership of the consultant1.txt file to consultants. So let's type change own :consultants and the file itself consultant1.txt. Now let's type ls-l consultant1.txt to list the new ownership of the consultant1.txt file. Now let's exit the shell and switch to the consultant2 user. I'll type exit and I'll type su-consultant2. Type in his password and navigate to the home consultants directory and ensure that the consultant2 user can add content to the consultant1.txt file. So I'll type cd command to change to the home consultants directory, use the echo command to add text to the consultant1.txt file. So I'll type echo double quotes text double quotes and then redirect this text to consultant1.txt file. I'll append this text to this file. Now let's use cat command to verify that the text was added to the consultant1.txt file. I'll type cat and the file's name and exit the shell. Managing default permissions and file access. After completing this video, you'll be able to control the default permissions of new files created by users, explain the effect of special permissions, use special permissions and default permissions to set the group owner of files created in a particular directory. Now, what is special permissions? Special permissions contribute a fourth permission type in addition to the basic user, group, and other types. As the name implies, these permissions provide additional access-related features over and above what the basic permission types allow. This video details the impact of special permissions summarized in several minutes. Now, what special permissions do we have? We have u plus s, it's a suid permission. In this case, file executes as the user that owns the file, not the user that ran the file. And it does not have an effect on directories. Next one is g plus s, it's sgid special permission. It's file executes as the group that owns the file. And files newly created in the directory have their group owner set to match the group owner of the directory. And the third special permission is O plus T. It's a sticky special permission. The effect on directories is users with write access to the directory can only remove files that they own. They cannot remove or force saves to files owned by other users. The set UID permission on an executable file means that commands run as the user owning the file, not as the user that ran the command. One example is the password command. Let's type ls-l usr bin password. In a long listing, you can identify the set UID permissions by a lowercase s, where you would normally expect the x to be. If the owner does not have execute permissions, this is replaced by an uppercase s. The special permission set GID on a directory means that files created in the directory inherit their group ownership from the directory, rather than inheriting it from the creating user. This is commonly used on group collaborative directories to automatically change a file from the default private group to the shared group, or if files in a directory should be always owned by a specific group. For example, /run/log/journal directory. Let's type ls-ld run log journal. If setGID is set on an executable file, commands run at the group that owns that file, not as the user that ran the command. In a similar way to setUID works. One example is a locate command. Let's type ls-ld usr bin locate. In a long listing, you can identify the setGID permissions by lowercase s, where you would normally expect x. Group execute permissions to be. If the group does not have execute permissions, this is replaced by an uppercase s. And lastly, the sticky bit for a directory that sets a special restriction on deletion of files. Only the owner of the file, and root of course, can delete files within the directory. An example is temp directory. Let's type ls-ld/tmp. In a long listing, you can identify the sticky permissions by lowercase t, where you would normally expect the x to be. If other does not have execute permissions, this is replaced by an uppercase t. And again, you can set special permissions in two ways, symbolically and numerically. To do it symbolically, type setuid equals u plus s, or g plus s, or o plus t. And to do it numerically, type setuid equals 4, or equals 2, or equals 1 for sticky special permission. So here 4 is for setuid, 2 is set for GID, and 1 for sticky. So let's create a directory right here and add the setGID bit on directory. I'll type chmod g plus s directory. To set the GID bit and add read-write execute permissions for user and group with no access for others on directory, I'll type the following: chmod 2770 directory. Now some words about default file permissions. When you create a new file or directory, it is assigned initial permissions. There are two things that affect these initial permissions. The first is whether you are creating a regular file or a directory, and the second is the current Umask. If you create a new directory, the operating system starts by assigning it octal permissions like 0777. If you create a new regular file, the operating system assigns it octal permissions like 0666. You always have to explicitly add execute permissions to a regular file. This makes it harder for an attacker to compromise a network service so that it creates a new file and immediately executes it as a program. However, the shell session will also set a Umask to further restrict the permissions that are initially set. This is an octal bit mask used to clear the permissions of a new files and directories created by a process. If a bit is set in the Umask, then the corresponding permission is cleared on new files. For example, the Umask 0002 clears the write bit for other users. The leading zeros indicate the special user and group permissions are not cleared. A Umask of 0077 clears all the group and other permissions of newly created files. The umask command without arguments will display the current value of the shell's umask. So let's try typing umask, and you'll see your current value of the shell's umask. Use the umask command with a single numeric argument to change the umask of the current shell. The numeric argument should be an octal value corresponding to the new umask value. You can omit any leading zeros in the umask. The system's default umask values for bash shell users are defined in the etc profile and etc bash rc files. Users can override the system defaults in the .bash_profile and .bash rc files in their home directories. Now let's review the umask example. The following example explains how the umask affects the permissions of files and directories. Look at the default umask permissions for both files and directories in the current shell. The owner and group both have read and write permission on files, and other is set to read. The owner and group both have read, write, and execute permissions on directories. The only permission for other is read. So let's type the following commands. Umask to see the current umask value. Then I'll type touch default and check it with ls-l default. And now I'll type mkdir to create a directory which will be called default. And again ls-ld default. Now by setting the umask value to 0, the file permissions for other change to read from read to read and write. The directory permissions for other changes from read and execute to read, write, and execute. So let's type umask 0. Now let's create a file touch0.txt and check it with ls-l0.txt. Now let's create a directory mkdir0 and check it with ls-ld0. To mask all file and directory permissions for other, set the umask value to 007. So let's type umask 007. Now let's create a file 7.txt with touch command. I'll type touch7.txt and check it with ls-l7.txt. Now let's create a directory with mkdir and the name is 7 and check it with ls-ld7. Another example, a umask of 027 ensures that new files have read and write permissions for user and read permissions for group. New directories have read and write access for group and no permissions for other. So let's type umask 027 touch2-7.txt ls-l2-7.txt to check the permissions. Now let's create a directory. I'll type mkdir2-7 and check it for permissions ls-ld27. Now, the default umask for users is set by the shell startup scripts. By default, if your account's UID is 200 or more and your username and primary group name are the same, you will be assigned a umask of 002. Otherwise, your umask will be 022. And as root, you can change this by adding a shell startup script named /etc/profile.d/local-umask.sh. And that looks something like the output of this example. So I'll type cat etc profile.d local-umask.sh to check the contents of this file in case it's there and you'd created it before. Now, to ensure that global umask changes take effect, you must log out of the shell and log back in. until the time the Umask configured in the current shell is still in effect. And this guided exercise will manage default permissions and file access. So you will control the permissions on few files created in a directory by using Umask settings and setID permission. After completing this guided exercise, you'll be able to create a shared directory where new files are automatically owned by the operators group. You'll be able to experiment with various Umask settings, adjust default permissions for specific users, and confirm your adjustment is correct. So first off, I'll su to the user operator1 using su- command and entering his password. And then I'll use the umask command to list the operator1 user's default umask value. As you can see, its value is 302. Now let's create a new directory named tmp shared in the tmp shared directory and create a file named defaults. And let's take a look at the default permission. So to do this, I'll type mkdir/tmp/shared, then I'll list this folder with ls-ld command, and I'll type /tmp/shared. Now let's use the touch command to create a file named defaults in the tmp shared directory, and use the ls-l command to list the permissions of the new created file. So I'll type ls-l/tmp/shared/defaults. Now let's change the group ownership of the temp shared folder or directory to operators and confirm the new ownership and permissions. To do this, I'll use the chown command to change the group ownership of the tmp shared directory to operators. So I type chown :operators tmp shared. And now let's use the ls-ld command to list the permissions of the tmp shared directory. Now let's use the touch command to create a new file named group in the tmp shared directory. I'll use the ls-l command to list the file permissions. So I'll type touch tmp shared group, and then I'll type ls-l tmp shared group. Please note that the group owner of the tmp shared group file is not operators, but operator1. Now let's ensure that files created in the tmp shared directory are owned by the operators group. I'll use the change-mode command to set the group ID to the operators group for the tmp shared directory. I'll type change-mode g+s/tmp/shared. And now I'll use the touch command to create a new file named operations_database.txt in the tmp shared directory. And I'll use the ls-l command to verify that operators group is the group owner for the new file. And as you can see, now this group is the owner. Now let's create a new file in the tmp shared directory named operations_network.txt. We'll also record the ownership and permissions, change the umask for operator1, and create a new file called operations_production.txt. Record the ownership and permissions of the operations_production.txt file. So to complete these tasks, I'll use the echo command to create a file called operations_network.txt in the tmp shared directory. So I'll type echo text append tmp shared operationsnetwork.txt. Now let's use the ls-l command to list the permissions of this file. And when we've noticed the permissions, let's use the umask command to change the umask for the operator 1 user to 027. And then use the umask command to confirm the change. So I'll type umask 027 and I'll type umask again and confirm that the mask is 2027. Now let's use the touch command to create a new file named operations_production.txt in the tmp shared directory, and use the ls-l command to ensure that the newly created files are created with read-only access for the operators group and no access for other users. So I'll type touch tmp shared operations_production.txt ls-l operations_production.txt, and as you can see, the permissions we needed are in place. Now let's open a new terminal window and log into the terminal with operator 1 user. Let's list the umask value for operator 1 user. We'll type umask, and as you can see, its default is 302. Now let's change the default umask for operator 1 user. The new umask prohibits all access for users not in their group and will confirm that the umask has been changed. So let's use the echo command to change the default umask for the operator 1 user to 207. I'll type echo in quotes, in double quotes, umask 227, close double quotes, and append to home directory .bashrc file. Now let's take a look at the contents of this file by typing cat:/.bashrc. As you can see, it's now umask 207. Now let's log out and log in again as the operator 1 user and use the umask command to confirm that the change is permanent. So I'll type exit, then I'll type operator 1 and his password, and I'll type umask to check that the change is permanent. Control and access to files. In this lab, you'll configure permissions on files and set up a directory that users in a particular group can use to conventionally share files on the local file system. As a result, you should be able to create a directory where users can work collaboratively on files, create files that are automatically assigned group ownership, and create files that are not accessible outside of the group. So first off, you have to create a directory called /home/tagdocs. The second step is to change the group ownership of the home tagdocs directory to the tagdocs group. If you haven't created a tagdocs group earlier, you should create this group now. The next step is to verify that users in the tagdocs group can create and edit files in the home tagdocs directory. Next up, you have to set up permissions on the home tagdocs directory. You have to configure setgid2 read-write execute permissions, 7 for the owner, user, and group, and no permissions, 0 for other users. Next up, you have to verify that the permissions are set properly. Confirm that users in the tagdocs group can now create and edit files in the home tagdocs directory. Users not in the tagdocs group cannot edit or create files in the home tagdocs directory. And users tag1 and tag2 are in the tagdocs group. User database1 is not in that group. The next step, you have to modify the global login scripts. Normal users should have a Umask setting that prevents others from viewing or modifying new files in the directories. Now, please pause here and complete these steps of the lab, and if you have any questions, you can move on and find the answers and solution for this lab further in this video. So let's review the solution. First off, we have to SSH to the Red Hat server and SU to the user root. Next step is to create a directory called home-tag-docs. So we'll use the mkdir command to create a directory called home-tag-docs. Next, we have to change the group ownership of the home-tag-docs directory to the tag-docs group. We'll type chown /tag-docs/home/tag-docs. Now we have to verify that the users in the tag-docs group can create and edit files in the home tag-docs directory. So I'll type su/tag1, use tag1's password, and then use the touch to create a file tag-doc1.txt in the home tag-docs directory. So I'll type touch home tag-docs tag-doc1.txt. Note that even though the home tag-docs directory is owned by tag-docs and tag1 is part of the tag-docs group, it is not possible to create a new file in that directory. This is because the tag-docs group does not have write permission. Use the ls-ld command to show the permissions. Now let's set the permissions on the home tag-docs directory, but first I'll exit from the tag1 user shell, and I'll use the chmod command to set the group permissions for the tag-docs directory. So I'll type chmod 2770 and the directory itself, home tag-docs. Now I have to verify the permissions are set properly, so I'll type ls-ld/home/tag-docs. Note that the tag-docs group now has write permissions. So let's confirm that the user in the tag-docs group can now create and edit files in this directory. And users not in the tag-docs group cannot edit or create files in the directory. And users tag1 and tag2 are in the tag-docs group, and user database1 is not in that group. So I'll switch to the tag1 user, use the touch command to create a file called tag-doc1.txt in this directory. For this I'll type su-tag1, then I'll type touch home tag-docs tag-doc1.txt, and I'll type ls-l for this file. Now I'll exit, I'll type logout and switch to tag2 user. So I'll type su-tag2 and I'll use the echo command to add some content to the tag-doc1.txt file. So I'll type echo and in double quotes, this is the first tag-doc, and redirect this content to /home/tag-doc/tag-doc1.txt. Now I'll type exit and switch to the database1 user and use echo command again to try to modify this file or append to this file. So I'll type su-database1, then I'll type echo, this is the first tag-doc in quotes, and try to append to this file. As you can see, we get permission denied. So I'll type ls-l home tag-docs tag-doc1.txt, and as you can see, we cannot access this file, permission denied. Now we have to modify the global login scripts in this lab so that normal users should have a Umask setting that prevents others from viewing or modifying new files and directories. So first I'll determine the Umask of the student user, and For this I'll use su-student command to switch to the student login shell. Then I'll type umask and exit. You can see the default umask now, it's 302. Now let's create a file in etcprofile.d folder and it will be called local-umask.sh file with the following content: to set the umask to 007 for users with a UID greater than 199 and with a username and primary group name that match, and to 022 for everyone else. So I'll type cat etcprofile.d local-umask.sh to view the contents of the file we've just created. Remember that to test that these settings are in place, you have to log out the shell and log back in as student to verify that global umask changes are set to 007. Monitoring and managing Linux processes. The goal for this section is to take a look at how to evaluate and control processes running on a Red Hat Enterprise Linux system. The objectives are to get information about programs running on the system so that you can determine status, resource use, and ownership, so you can control them. Another objective is to use bash job control to multiply processes started from the same terminal session. Also, you'll control and terminate processes that are not associated with your shell and forcibly end user sessions and processes. You'll also describe what load average is and determine processes responsible for high resource use on a server. So we'll be having the next topics. We'll have listing processes and we'll also have a quiz here. We'll have control and job and we'll have a guided exercise here. We'll have a killing processes and we'll have a guided exercise here as well, and monitor and processes activity with guided exercise. Later on we'll have a lab on this monitoring and managing Linux processes section. So let's get started. And we are starting with listing processes. After completing this video, you should be able to get information about programs running on a system to determine status, resource use, and ownership so you can control them. So, what is a process? A process is a running instance of a launched executable program. A process consists of an address space of allocated memory, security properties including ownership, credentials, and privileges, one or more execution threads of program code, and a process state. The environment of a process includes local and global variables, a current scheduling context, and allocated system resources such as file descriptors and network ports. An existing parent process duplicates its own address space, fork, to create a new child process structure. Every new process is assigned a unique process ID or PID for tracking and security. The PID and the parent's process ID or PPID are elements of the new process environment. Any process may create a child process. All processes are descendants of the first system process, which is systemd, on a Red Hat Enterprise Linux 8 system. Though the fork routine, a child process inherits security identities, previous and current file descriptors, port and resource privileges, environment variables, and program code. A child process may then exec its own program code. Normally, a parent process sleeps while the child process runs. Setting a request or wait to be signaled when the child completes. Upon exit, the child process has already closed or discarded its resources and environment. The only remaining resource, called a zombie, is an entry in the process table. The parent, signaled awake when the child exited, cleans the process table of the child's entry, thus freeing a last resource of the child process. The parent process then continues with its own program code execution. Now let's take a look at process states. In a multitasking operating system, each CPU or CPU core can be working on the process at a single point of time. As a process runs, its immediate requirements for CPU time and resource allocation change. Processes are assigned a state which changes as circumstances dictate. So we have several different process states. Let's take a look at them. We have running process state with R flag, which means task running. In this state, the process is either executing on a CPU or waiting to run. Process can be executing user routines or kernel routines or system calls, or be queued and ready when in the running or runnable state. So please remember, running process state is a flag R. The next state is sleeping with several flags. We have a flag S, which means task interruptible. In this state, the process is waiting for some condition, a hardware request, system resource access or signal, and when an event or signal satisfies the condition, the process returns to running. Another flag for sleeping state is D, or task uninterruptible. In this state, the process is also sleeping, but unlike S state, does not respond to signals. Used only when process interruption may cause an uninterruptible device state. Another flag is K, or task killable. In this state, it's identical to the uninterruptible or D state, but modified to allow a waiting task to respond to the signal that it should be killed or exited completely. Utilities frequently display killable processes as D state. So to recap, in sleeping process state, we have three flags, S, D, K. S is task interruptible, D is task uninterruptible, and K task killable. Another process state is stopped with two flags, T and T. So the first flag T is task stopped. The process has been stopped, suspended, usually by being signaled by a user or another process. The process can be continued or resumed by another signal to return to running. And another state is T task traced. A process that is being debugged is also temporarily stopped and shares the same T state flag. And the last state for processes is zombie, with two flags, Z and X. Z is for exit zombie. A child process signals its parent as it exits. All resources except for the process identity or PID are released. And X flag is exit dead. When a parent cleans up or rips the remaining child process structure, the process is now released completely. This state will never be observed in process listing utilities. Now, why process states are important? When troubleshooting a system, it is important to understand how the kernel communicates with processes and how processes communicate with each other. At process creation, the system assigns the process a state. The S colon of the top command or the stat column of the ps command shows the state of each process. On a single CPU system, only one process can run at a time. It is possible to see several processes with a state of R. However, not all of them will be running consequently. Some of them will be in a state waiting. Process can be suspended, stopped, resumed, terminated, and interrupted using signals. Signals are discussed in more detail later in this video. Signals can be used by other processes, by the kernel itself, or by users logged into the system. Listing processes. The ps command is used for listing current processes. It can provide detailed process information, including user identification, UID, unique process identification or PID, CPU and real-time already expanded, how much memory the process has allocated in various locations, the location of process std out, known as controlling terminal, and the current process state. There are several versions of ps command with different options. Perhaps the most common set of options, or AUX, displays all processes including processes without a controlling terminal. There is also a long listing option, or LAX, which provides more technical detail but may display faster by avoiding username lookups. Or there is an option with -EF to display all processes. By default, PS with no options selects all processes with the same effective user ID or EUID as the current user and which are associated with the same terminal where PS was invoked. Processes in brackets, usually at the top of the list, are scheduled kernel threads. Zombies are listed as exiting or defunct, and the output of PS displays once as useTop for a process display that dynamically updates. PS can display in tree format so you can view relationships between parent and child processes. The default output is sorted by process ID. At first glance, this may appear to be chronological order. However, the kernel reuses processes IDs so that the order is less structured than it appears. To sort, use the -O or two dashes sort options. Display order matches that of the system process table, which reuses table rows as processes die and new ones are created. Output may appear chronological but is not guaranteed unless explicit -O or two dashes sort options are used. Now, for additional information, you can reference to info libc signal section 24 and info libc processes section 26, and to read more about this topic. Controlling jobs. After completing this video, you should be able to use bash job control to manage multiple processes started from the same terminal, or better to say terminal session. Job control is a feature of the shell which allows a single shell instance to run and manage multiple commands. A job is associated with each pipeline entered at a shell prompt. All processes in that pipeline are part of the job and are members of the same process group. If only one command is entered at a shell prompt, that can be considered to be a minimal pipeline of one command, creating a job with only one member. Only one job can read input and keyboard generated signals from a particular terminal window at a time. Processes that are part of that job are foreground processes of that control in terminal. A background process of that control in terminal is a member of any other job associated with that terminal. Background processes of a terminal cannot read input or receive keyboard-generated interrupts from the terminal, but may be able to write to the terminal. A job in the background may be stopped or suspended, or it may be running. If a running background job tries to read from the terminal, it will be automatically suspended. Each terminal is its own session and can have a foreground process and any number of independent background processes. A job is a part of exactly one session, the one belonging to its controlling terminal. The ps command shows the device name of the controlling terminal of a process in the TTY column. Some processes, such as system daemons, are started by the system and not from a shell prompt. These processes do not have a controlling terminal, are not members of a job, and cannot be brought to the foreground. The ps command displays a question mark in the TTY column for these processes. So, running jobs in the background. Any command or pipeline can be started in the background by appending an ampersand symbol to the end of the command line. The bash shell displays a job number, it's unique to the session, and the PID of the new child process. The shell does not wait for the child process to terminate, but rather displays the shell prompt. Let's run the following command: sleep 10,000 followed by ampersand. Please note that when a command line containing a pipe is sent to the background using an ampersand, the PID of the last command in the pipeline is used as output. All processes in the pipeline are still members of that job. As an example, you could have the following: some command, then pipe, sort, pipe, and another command, followed by ampersand symbol. Now remember this command with run sleep 10,000. You can display the list of jobs that bash is tracking for a particular session with the jobs command. So let's run jobs and we'll find out our command is still running. The job is still running. A background job can be brought to the foreground by using the fg command with its job ID. So to bring this job running in the background, we could type fg or foreground %1. In this preceding example, the sleep command is now running in the foreground on the controlling terminal. The shell itself is again asleep, waiting for the child process to exit. We can send a foreground process to the background. To do this, we have to press the keyboard-generated suspend request, and we have to press Ctrl+Z in the terminal. So let's do this, and the job is immediately placed in the background and is suspended. The psj command displays information relating to jobs. The PID is the unique process identifier of the process. The PPID is the PID for the parent process in this process, the process that started or forked it. The PGID is the PID for the process group leader, normally the first process in the jobs pipeline. The SID is the PID of the session leader, which is normally the interactive shell that is running on its controlling terminal. Since the example sleep command is currently suspended, its process state is T. And to start the suspended process running in the background, we can use the bg command with the same job ID. So let's type bg %1. Please also note that the shell will warn a user who attempts to exit a terminal window with suspended jobs. If the user tries exiting again immediately, the suspended jobs are killed. Also, please note the plus sign after the jobs identifier 1, for example. It indicates that this job is the current default job. That is, if a command is used that expects a % job number argument and a job number is not provided, then the action is taken on the job with a plus indicator. Welcome to guided exercise on controlling jobs. In this exercise, you'll start, suspend, background, and foreground multiple processes using job control. After completing this exercise, you should be able to use job control to suspend and restart user processes. So the first step is to connect to the terminal via SSH, and then I'll create a new directory called home student bin. In the new directory, I'll create a shell script called control and make the script executable. So to perform this task, we need to type mkdir home student bin and then type the following command: vim home student bin control, and add the following content to this script. We'll start the script with shebang. This first line is called shebang. It starts with dash exclamation mark and then the path to the interpreter. In our case, it's bash interpreter and it is located in bin bash. Then we'll type the simple script with while loop. So we'll type while true, do, echo command, and redirect it or append it to the file located in the home directory, which is called control_out file, and then followed by the sleep command and end of while loop with done command. Please note that this control script runs until terminated. It appends command line arguments to the mentioned file once per second. Now we have to use the change mode command with the +X option to make the control file executable. So I'll type change mode +X home student bin control and run the script. The script continuously appends the word technical and a space to the file control_out file at 1 second intervals. Please note that you are able to run your control script because it is located in your path and has been made executable. So let's run it. We'll type control followed by technical. Now I have another terminal shell opened, and in this right terminal shell I'll use the tail command with the -F option to confirm that the new process is right into the file. So I'll type tail -F /control_out file. Now let's press Control plus Z to suspend the running process in the first terminal or left terminal. And in this case, the shell returns the job ID in square brackets and the output is stopped. Now let's type jobs to view the jobs list. Remember that the plus sign indicates the default job. Let's restart the job in the background, and in the second terminal, shell will confirm that the process output is again alive or active. So I'll type jobs, then I'll type BG. It will restart the control job in the background, and then I'll use jobs command to confirm that the control job is running again. And in the second terminal, I'll confirm with the tail command that the job is producing output. Now in the first terminal shell, I'll start 2 more control processes to append to the output file. I'll use the ampersand to start the processes in the background. and I'll replace technical word with documents word and then the database word. This replacing the arguments will help to differentiate between the three processes. So I'll type control documents ampersand, and I'll type control database ampersand, and I'll get the output with the jobs ID and number. The job number of each new process is printed in square brackets. And as you remember, the second number is a unique system-wide process ID or PID for the process. Now in the first terminal, I'll use jobs command to view the three running processes. In the second terminal shell, I'll confirm that all three processes are appended to the file. Now let's suspend the control technical process and confirm that it has been suspended, and terminate the control documents process and confirm that it has been terminated. So in the first terminal shell, I'll use the fg command with the job ID to foreground the control technical process. Then I'll press Ctrl plus Z to suspend the process. And I'll type the jobs command to confirm that the process is suspended. So let's type fg %1, and after it is brought to the foreground, let's type Ctrl plus Z. Let's type jobs again. We can see that we have one stopped and two running jobs. And now let's use fg command again with the job ID to foreground the control documents process, and press Ctrl plus C to terminate the process. So let's type fg %2 Ctrl plus C and type jobs again. Now in the second terminal shell, let's confirm that the control documents process is no longer sending output. Again, let's switch to the first terminal shell and type ps command with the J_T option to view the remaining jobs. The suspended jobs have a state of T. The other background jobs are sleeping with the state of S. Killing processes. After completing this video, you should be able to use commands to kill and communicate with processes, define the characteristics of a daemon process, and end user sessions and processes. Now, process control using signals. A signal is a software interrupt delivered to a process. Signals report events to an executing program. Events that generate a signal can be an error, external event such as an I/O request or an expired timer, or by explicit request, that is a signal sending command or a keyboard sequence. So whenever you press Ctrl+C or Ctrl+Z, it is an explicit request. Let's review the list of fundamental signals used by system administrators for routine process management. The signal under number 1, short name for it is HUP or hub. The definition for this signal is hang up. This signal is used to report termination of the controlling process of a terminal, also used to request process reinitialization or configuration reload without termination. Signal number 2, it's INT or int signal. It's a keyboard interrupt such as Ctrl+C. Signal number 3, quit. It's a keyboard quit. It's sent by pressing quit key combination, like Ctrl+\. Signal number 9, it's a kill signal, causes abrupt program termination, cannot be blocked, ignored, or handled. Signal number 15 terminates a process. It causes program termination, but unlike kill, can be blocked, ignored, or handled. It's the polite way to ask a program to terminate and allow self-cleanup. Signal number 18, its abbreviation is cont or continue. It's sent to a process to resume if stopped. It cannot be blocked. Even if handled, always resumes the process. Signal number 19, stop. It suspends the process, cannot be blocked or handled. And signal number 20, TSTP or keyboard stop, sent by pressing Ctrl+Z or SASP key combination. Now, signal numbers vary on different Linux hardware platforms, but signal names and meanings are standardized. For command use, it is advised to use signal names instead of numbers. Each signal has a default action, usually one of the following: term, core, or stop. Term cause a program to terminate or exit at once. Core cause a program to save a memory image or core dump, then terminate. And stop causes a program to stop executing or suspend and wait to continue or resume. You already know some commands for sending signals by explicit request. By pressing a keyboard control sequence to suspend, you press Ctrl+Z, to kill Ctrl+C, or to core dump Ctrl+\. However, you will use signal sending commands to send signals to a background process or to processes in different sessions. Signals can be specified as options either by name, for example -hup or -sighub, or by number. Users may kill their own processes, but root privilege is required to kill processes owned by others. So the kill command sends a signal to a process by PID number. Despite its name, the kill command can be used for sending any signal, not just those for terminating programs. You can use the kill-l command to list the names and numbers of all available signals. So let's type kill-l, and you can see the list of 20, in my case the list of 20 signals. So we can get a process ID or PID and then kill this process with kill command. So you can type ps command to get the PID, and then you could type kill and the PID followed by the PID of the process. Also, you could send the kill with a signal, for example kill-9 and the PID followed by the PID. You could also use a kill all command to terminate or send the signal, the needed signal, to multiple processes. Use pkill to send a process to one or more processes which match selection criteria. Selection criteria can be a command name, a process owned by a specific user, or all system-wide processes. The pkill command includes advanced selection criteria. You can select by command, UID, git, parent, or terminal. You can also specify the processes for some specific user. Now, logging users out administratively. You may need to log other users off for any of a variety of reasons. For example, a user committed a security violation or overused resources and so on. So to log off a user, first identify the login session to be terminated. For this, you could use the W command to list user login and current running processes. Here you have to know the TTY and from columns to determine the sessions to close. So first identify the PID number to be killed using pgrab, which operates much like pkill, including using the same options, except the pgrab lists processes rather than killing them. So you could type pgrab-l-u and the username. Then you could use the pkill-sigkill, for example, -u and the user's name. you could specify the TTY for this particular user, or kill all the processes for some specific TTY. The same selective process termination can be applied using parent and child process relationships. And you can use the ps_tree command to view a process tree for a system or a single user. And you can use the parent process's PID to kill all children they have created. So you could type ps_tree -p and the user's name, and then you could type pkill -P and the process's ID. In this video we'll be talking about monitoring process activity, and after completing this section you should be able to describe what load average is and determine processes responsible for high resource use on a server. Load average is a measurement provided by the Linux kernel that is a simple way to represent the perceived system load over time. It can be used as a rough estimate of how many system resource requests are pending and to determine whether system load is increasing or decreasing over time. Every 5 seconds, the kernel collects the current load number based on the number of processes in runnable and uninterruptible states. This number is accumulated and reported as an exponential moving average over the most recent 1, 5, and 15 minutes. Now, the load average represents the perceived system load over a time period. A Linux determines this by reporting how many processes are ready to run on a CPU and how many processes are waiting for disk or network I/O to complete. The load number is essentially based on the number of processes that are ready to run, or in process state R, and are waiting for I/O to complete, or in process state D. Some Unix systems only consider CPU utilization or run queue length to indicate system load. Linux also includes disk or network utilization because that can have a significant impact on system performance as CPU load. When experiencing high load averages with minimal CPU activity, examine disk and network activity. Load average is a rough measurement of how many processes are currently waiting for a request to complete before they can do anything else. The request might be for CPU time to run the process. Alternatively, the request might be for a critical disk I/O operation to complete, and the process cannot be run on the CPU until the request completes, even if the CPU is idle. Either way, system load is impacted and the system appears to run more slowly because processes are waiting to run. Now, interpreting displayed load average values. And for this purpose, you can use one of the commands such as uptime. The uptime command is one way to display the current load average. It prints the current time, how long the machine has been up, and how many user sessions are running, and the current load average. So you can go ahead and type uptime. Here, the 3 values for the load average represent the load over the last 1, 5, and 15 minutes. A quick glance indicates whether system load appears to be increasing or decreasing. If the main contribution to load average is from processes waiting for the CPU, you can calculate the appropriate per CPU load value to determine whether the system is experiencing significant waiting. Now, another command is ls_cpu command. This command can help you determine how many CPUs a system has. So go ahead and run this command and you'll see the output of the information about your CPU. For a moment, imagine that the only contribution to the load number is from processes that need CPU time. Then you can divide the displayed load average values by the number of logical CPUs taken from the output of this command. We have a number of additional tools report load average, including W command and top command. Now some words about top command to refresh your knowledge on this very useful tool. Top command is for real-time process monitoring, and it is a dynamic view of the system's processes displaying a summary header followed by a process or thread list similar to the PS information. Unlike the static PS output, top continuously refreshes at a configurable interval and provides capabilities for column reordering, sorting, and highlighting. Using configurations can be saved and made persistent. Default output columns are recognizable from other resource tools. We have the process ID, PID, the username, user is the process owner, virtual memory or virt is all memory the process is using, including the resident set, shared libraries, and any mapped or swapped memory pages. We've got resident memory, res, in the physical memory used by the process, including any resident shared objects. And also we can have process state or S displayed as D uninterruptible sleeping, R running or runnable process, S sleeping, T stopped or traced, and Z for zombie process. CPU time or time is the total processing time since the process started, and we've also got process command name or command. Let's try to push some fundamental keystrokes in top command. There are several keys, and the first one is H. The purpose of this key is to get help for interactive keystrokes. Then there are 3 keys for load, threads, and memory header lines, and these are L, T, and M respectively. So you could go ahead and push these keys to experiment with the top command. Try to push L key, H key, T key, or M key. Then if you push one key, it toggles showing individual CPUs or a summary for all CPUs in header. The S key changes the refresh screen rate in decimal seconds. B key toggle reverse highlighting for running processes. The default is bold only. Then we have Shift plus H keystroke. It toggle threads, showing processes summary or individual threads. The U key or Shift U filters for any username. The Shift plus M key sorts process listing by memory usage in descending order. And finally, Shift plus P key sorts processes listing by processor utilization in descending order. We've also got K key, it kills a process when prompted. You have to enter PID, then signal. R key, renice a process. When prompted, enter PID and then nice value. And Shift plus W saves the current display configuration for use at the next top restart. If you don't press this keystroke, when you quit the top command, it will go to defaults. And finally, the Q key quits the top command. And of course, you can refer to the references for these commands like PS command, top, uptime, and W man pages. It's time for the lab exercises on monitoring and managing Linux processes. So in this lab, you'll locate and manage processes that are using the most resources on a system. After this lab, you'll be able to manage processes using top as a process management tool. So first off, we'll log in onto our virtual machine, and I'll open several terminal windows side by side for this lab, or I'll be minimizing and maximizing different terminal windows to perform these exercises. The first step will be to create a script called process 101, which will generate artificial CPU load. We'll create the script in the home directory and bin directory in it. So the script looks like this: shebang /bin/bash, new line, while true, do var equals 1, and then the next loop, while var less than 500, do var, and we'll be adding +1 to this variable. Close while loop and sleep for 1 second. I'll remind you that I'm adding these lines in Vim editor, and to run Vim editor just type Vim, and to enter interactive mode in Vim press I. When you've done typing the lines, type :WQ to save the file, and you save it in your home directory under bin directory and call it process 101. Now let's make the process 101 file or script executable with the change mode command and the +X option. So we'll type change mode +X and the path to our script. In another window, I'll run top utility to monitor the system resources usage. Now let's run the process 101 script in the background and check with the grep command to determine the number of logical CPUs. So first we'll type grep in double quotes mode 1 name /proc/CPU info pipe wc-l. And second, let's run the script. I'll change directory to the home directory, bin directory, and run process 101 ampersand, followed by ampersand. And now you can observe in the second terminal window the top display. You can toggle between load, threads, and memory, and note the process ID or PID for process 101. You can view the CPU percentage. It should hover over 10 to 15%, and ensure that top is showing CPU usage once you have viewed load, threads, and memory. So to do all these steps, you can press Shift+M, Shift+L. Please note that when top is switched into memory mode, process 101 is no longer the first process. You can press Shift+P to return to CPU usage. Now try pressing T command and then press Shift+P again. Shift+B to switch the use of bolt off. So Shift+B turns off the use of bolt in the display. And if you want to save this configuration for reuse when top is restarted, confirm that the changes are saved. So you'll press Shift+W to save the configuration, and the default configuration is stored in the .top.rc in the homes directory, .config directory, proc ps directory. And you can confirm that this file exists in the second terminal window. You could type ls-l home, in my case it's shumi, .config proc ps top rc. You have to restart the top command to confirm that the new display uses the saved configuration. Now let's copy the process 101 script to a new file called process 102. We'll edit the script to create more artificial CPU load and will increase the load from 50,000 to 100,000. We'll start the process 102 in the background as well. So in the terminal shell, I'll use cp command to copy process 101 to process 102. Now I'll use vim again to edit process 102 script, and I'll increase the additional load from 50,000 to 100,000. So to do this, I'll enter interactive mode by using the I command, and then I'll type :wq to save the file. And now, when we are done, let's start the process 102 in the background. I'll type process 102 followed by ampersand. And now we can check that both processes are running in the background using job command. So I'll type jobs. As you can see, we've got two running jobs, process 101 and process 102. Now, in the second terminal shell, I'll confirm that process is running and using the most CPU resources. Now, the load should be hovering from 25% to 35%. Please note that if you do not see process 101 and process 102 at the top of the process list, you have to press Shift plus P to ensure that top is sorted by CPU utilization. Now let's add even more load to our system, and let's copy again the process 101 to a new script called process 103, and we'll increase the additional count to 800,000. So we'll do the same steps by copying with the copy command, cp command. We'll type cp process 101, process 103, and then we'll use the vim command to edit the process 103 script, and we'll change the load by entering interactive mode using I key, and then we'll type :wq to save the file and run the process 103 in the background. Now the CPU usage can hover between 60 and 85%. Again, to check the running processes, you could type jobs to see 3 jobs, namely process 101, 2, and 3. Now, in the left terminal shell will become root and suspend the process 101 and list remaining jobs. So we'll use su- command to become root, and we'll use the pkill or pkill command with the -sig-stop option to suspend the process 101. I'll type pkill -sig-stop process 101. And in the right terminal window, I'll confirm that process 101 is no longer running. Now, in my left terminal shell, I'll run ps command with the J capital T to view the remaining jobs. And I'll note that process 101 has a status of T. This denotes that the process is currently suspended. Now let's resume the process 101. And in the left terminal shell, I'll use pkill command again with the -sig-cont option to resume the process 101. We can guess that sig-cont is signal continue. So I'll type pkill -sig-cont process 101. And in the right terminal shell, I'll confirm that the process is running again. Now let's terminate process 101, 2, and 3 using the command line and confirm that the processes no longer display in top. So in the left terminal shell, I'll use pkill command again to terminate these processes. I'll type pkill process 101, repeat it with the process 102 and 3. And I'll check that the processes are no longer displaying in top in my right terminal shell with the top command. And this will finish our lab on processes, monitoring and managing processes. And as a brief summary, in this section we've learned a process and that a process is a running instance of an executable program. Processes are assigned a state which can be running, sleeping, stopped, or zombie. The ps command is used to list processes. Each terminal is its own session and can have foreground process and independent background processes. The jobs command displays processes within a terminal session. A signal is a software interrupt that reports events to an executing program. The kill, pkill, and kill all command use signals to control processes. And load average is an estimate of how busy the system is. To display load average values, you can use the top command, uptime command, or W command. Controlling services and daemons. The goal for these several videos is to take a look at how to control and monitor network services and system daemons using systemd. After completing these videos, you'll be able to list system daemons and network services started by the systemd service and socket units. You'll be able to control system daemons and network services using Systemctl. We'll take a look on how to identify automatically started system processes and how to control system services. So the systemd daemon manages startup for Linux, including service startup and service management in general. It activates system resources, server daemons, and other processes both at boot time and on a running system. Daemons are processes that either wait or run in the background, performing various tasks. Generally, daemons start automatically at boot time and continue to run until shutdown, or until they are manually stopped. It is a convention for names of many daemon programs to end in the letter D. A service in the systemd sense often refers to one or more daemons, but starting or stopping a service may instead make a one-time change to the state of the system, which does not involve leaving a daemon process running afterwards. In Red Hat Enterprise Linux, the first process that starts, or PID1, is systemd. A few of the features provided by systemd include parallelization capabilities, which is starting multiple services simultaneously, which increase the boot speed of a system. Another feature is on-demand starting of daemons without requiring a separate service. Next one is automatic service dependency management, which can prevent long timeouts. For example, a network-dependent service will not attempt to start up until the network is available. And the last feature is a method of tracking related processes together by using Linux control groups. So, systemd uses units to manage different types of objects. Some common unit types are as follows. We've got service units which have a .service extension and represent system services. This type of unit is used to start frequently accessed daemons, such as a web server. Another type is socket unit, which have a .socket extension and represent inter-process communication, or IPC. Sockets that systemd should monitor. If a client connects to a socket, systemd will start a daemon and pass the connection to it. Socket units are used to delay the start of a service at boot time and to start less frequently used services on demand. Another type of units is path units, which have a .path extension and are used to delay the activation of service until a specific file system change occurs. This is commonly used for services which use spool directories such as a printing system. The Systemctl command is used to manage these units. For example, display available unit types with the Systemctl-t help command. Now, you use the Systemctl command to explore the current state of the system. For example, the following command lists all currently loaded service units, paginating the output using less. So you press spacebar to list the screens. So let's type Systemctl list-units 2 dashes type equals service. This output limits the type of unit listed to service units with the -- type equals service option. The output has the following columns. There is unit column, that is the service unit name. Load column, that is where the systemd properly parsed the unit's configuration and loaded the unit into memory. Active column, this column is the high-level activation state of the unit. This information indicates whether the unit has started successfully or not. We've got subcolumn, the low-level activation state of the unit. This information indicates more detailed information about the unit. The information varies based on unit type, state, and how the unit is executed. And the description column, that is the short description of the unit. By default, the Systemctl list-units 2 dashes type equals service command lists only the service units with the active activation states. The 2 dashes all option lists all service units regardless of the activation state. So use the 2 dashes state equals option to filter by the value in the load, active, or sub fields. The Systemctl command without any arguments lists units that are both loaded and active. The Systemctl list-units command displays units that the systemd service attempts to parse and load into memory. It does not display installed but not enabled services. To see the state of all unit files installed, you can use the Systemctl list-unit-files command. For example, you could try typing Systemctl list-unit-files 2 dashes type equals service. If we type the following command Systemctl list-units-files, the output of this command will show valid entries for the state field, which is enabled, disabled, static, and masked. Now, to view the status of a specific unit with Systemctl status command, you type as follows: Systemctl status name.type. And if the unit type is not provided, Systemctl will show the status of a service unit if one exists. For example, we could type Systemctl status shd.service. This command will display the current status of the service and the following fields. The meaning of these fields are as follows. Loaded, it means whether the service unit is loaded into memory. Active, it means whether the service unit is running, and if so, how long it has been running. Main PID, it means the main process ID of the service, including the command name. And status, it means additional information about the service. Several keywords indicating the state of the service can be found in the status output. So we've got such keywords as loaded, which is for unit configuration file has been processed. Active running, it means that they're running with one or more continuing processes. Active exited means successfully completed a one-time configuration. Active waiting means running but waiting for an event. Inactive, not running. Enabled is started at boot time. Disabled means is not set to be started at boot time. And static cannot be enabled but may be started by an enabled unit automatically. Now, how to verify the status of a service? The Systemctl command provides methods for verifying the specific states of a service. For example, we can use the following command to verify that the service unit is currently active or running. We could type systemctl is-active shd.service. The command returns state of the service unit, which is usually active or inactive. We can run the following command to verify whether a service unit is enabled to start automatically during system boot. Let's type systemctl is enabled shd.service. The command returns whether the service unit is enabled to start at boot time, which is usually enabled or disabled. To verify whether the unit failed during startup, you can run the following command. Systemctl is failed ssh.service. The command either returns active if it is properly running or failed if an error has occurred during startup. In case the unit was stopped, it returns unknown or inactive. Now, to list all the failed units, you can run the systemctl -failed -type equals service command. And of course, you can read manuals for systemd, systemd.unit, systemd.service, and systemd.socket, and systemctl man pages. Let's perform some more exercises on identifying automatically started system processes. So first, let's list all service units installed on the server. I'll type systemctl list-units -type equals service. And when I'm done, I'm pressing Q to exit the command. Second, let's list all socket units active and inactive on this server. So I'll type systemctl list-units -type equals socket, and then followed by 2 all. Now let's explore the status of the cron-id service. This service is used for network time synchronization, or NTP. Let's display the status of the cron-id service. Please note that the process ID of any active daemons. So I'll type systemctl status cron-id. Now let's confirm that the listed daemons are running, and I'll get the output of the previous command and the process ID associated with cron-id service, and I'll type ps-p and the process ID itself. Please note that this process ID might be differ on your system. Now let's explore the status of the SSHD service, and this service is used for secure encrypted communication, as you know, between systems. So first, let's determine whether the SSHD service is enabled to start at system boot. So I'll type systemctl is enabled SSHD. Now let's determine if the SSHD service is active without displaying all the status information. So I'll type systemctl is active SSHD. Now let's display the status of the SSHD service. I'll type systemctl status SSHD. And when I'm done, I'm pressing Q to exit the command. Now let's list the enabled or disabled states of all service units. So I'll type systemctl list-unit-files, then followed by 2 dashes type equals service. And again, when I'm done, I'm pressing Q to exit the command. Now, when we've done performing the exercises on previous video, let's switch on to controlling system services. And we'll start with starting and stopping services. As you know, services need to be stopped or started manually for a number of reasons. Perhaps the service needs to be updated, the configuration file may need to be changed, or a service may need to be uninstalled, or an administrator may manually start an infrequently used service. Now, to start a service, first verify that it is not running with systemctl status. Then use the systemctl start command as the root. We can use sudo if necessary. So let's try the following command: sudo systemctl start sshd.service. Also, please note that systemd service looks for .service files for service management and commands in the absence of the service type with the service name. Thus, we could perform the preceding command with the following: systemctl start sshd, omitting .service part. Now, to stop a currently running service, use the stop argument with the systemctl command. Let's perform the following example: systemctl stop sshd.service. We can also restart and reload services. During a restart of a running service, the service is stopped and then started. On the restart of service, the process ID changes and a new process ID gets associated during the startup. To restart a running service, use the restart argument with the systemctl command. Let's perform the following command: systemctl restart sshd.service. Some services have the ability to reload their configuration files without requiring a restart. This process is called a service reload. Reloading a service does not change the process ID associated with various service processes. To reload a running service, use the reload argument with the systemctl command. So let's try systemctl reload sshd.service. In case you are not sure whether the service has the functionality to reload the configuration file changes, you can use the reload-or-restart argument with the systemctl command. The command reloads the configuration changes if the reloading functionality is available. Otherwise, the command restarts the service to implement the new configuration changes. So let's try the following: systemctl reload or restart sshd.service. We can also list unit dependencies, as some services require that other services be running first, creating dependencies on the other services. Other services are not started at boot time, but rather only on demand. In both cases, systemd and systemctl start services as needed, whether to resolve the dependency or to start an infrequently used service. For example, if the cups print service is not running and a file is placed into the print spool directory, then the system will start cups-related daemons or commands to satisfy the print request. So let's try typing the following command: systemctl stop cups.service. Now, to completely stop printing service on a system, stop all three units. Disabling the service disables the dependencies. The systemctl list dependencies followed by the unit name command displays a hierarchy mapping all of the dependencies to start the service unit. To list reverse dependencies, you can use the --reverse option with the command. So let's type systemctl list dependencies sshd.service, and we'll get the whole list of the dependencies. Now some words about masking and unmasking services. Because at times a system may have different services installed that are conflicting with each other. For example, there are multiple methods to manage mail servers, like postfix and send mail, for example. Masking a service prevents an administrator from accidentally starting a service that conflicts with others. Masking creates a link in the configuration directories to the /dev/null file, which prevents the service from starting. So you can type the following command: systemctl mask sendmail.service to mask a sendmail service. And now when we are checking this service, we'll get the masked status for this service. Or we can type systemctl list unit files type equals service and find the sendmail service with the state masked. Now if we attempt to start a masked service unit, it will fail with the following output: failed to start and the service which we are attempting to start, which is masked. In our case it's sendmail. So if we type systemctl start sendmail.service, we'll get this error message. Now we can unmask this service if we need. We'll type the following: systemctl unmask sendmail, and again this service can be started and function on our system. Now, if we want to enable services to start or stop at boot, we can do this. Starting a service on a running system does not guarantee that the service automatically starts when the system reboots. So, similarly, stopping a service on a running system does not keep it from starting again when the system reboots. Creating links in the systemd configuration directories enables the service to start at boot. The systemctl command creates and removes these links. To start a service at boot, we can use systemctl enable command. So let's type systemctl enable sshd.service, and we'll get the following message that the symlink was created. This above command creates a symbolic link from the service unit file, usually in the usr lib systemd system directory, to the location on disk where systemd looks for files, which is in the etc systemd system and the target directory. Enabling a service does not start the service in the current session. To start the service and enable it to start automatically during boot, you can execute both the systemctl start and systemctl enable commands. And similarly, you can disable the service from starting automatically. You can use the following command, which removes the symbolic link created while enabling a service. And also, disabling a service does not stop the service. So we can type the following: systemctl disable sshd.service. And again, to verify whether the service is enabled or disabled, you can use systemctl isEnabled command. Now, to briefly wrap up the commands we've used, let's recall the most useful of them. We can type systemctl status, stop, start, restart, reload, mask, unmask, or enable and disable commands. And also we have the systemctl list-dependencies command. Configuring and securing SSH. The goal for the next few lessons will be to configure secure command line service on remote systems using OpenSSH. We'll be logging into a remote system and running commands using SSH. We'll be configuring key-based authentication for a user account to log into remote systems securely without a password. And we'll be restricting direct logins as root and disabling password-based authentication for the OpenSSH service. There will be three main parts for these lessons: accessing the remote command line with SSH, configuring SSH key-based authentication, and customizing OpenSSH service configuration. Now, what is OpenSSH? OpenSSH implements the secure shell or SSH protocol in the Red Hat Enterprise Linux systems. And of course, we can use it on other systems like Ubuntu or SUSE Linux. The SSH protocol enables systems to communicate in an encrypted and secure fashion over an insecure network. You can use the SSH command to create a secure connection to a remote system, authenticate as a specific user, and get an interactive shell session on the remote system as that user. You may also use the SSH command to run an individual command on the remote system without running an interactive shell. So let's take a look at a few examples of using SSH command. The next command is used to log you in on the remote server. In my case, it's an IP address using the same username as the current local user. In this example, the remote system prompts you to authenticate with that user's password. So to do this, you just type SSH and remote host name or IP address, as in my case. You can use the exit command to log out the remote system. The next example is that SSH command would log you in on the remote server using the username. In my case, it's temp user. Again, you are prompted by the remote system to authenticate with that user's password. So you can type SSH, username you want to remotely log in, and remote host name. In my case, it's NAS. Next, SSH command would run the host name command on the remote host system as the user temp without accessing the remote interactive shell. So we'd type the following command: SSH temp at NAS and the command. In this case, it's host name. Again, we are prompted for the password for this user, and the command is executed. And in this case, please note that the preceding command displayed the output in the local system's terminal. Sometimes we need to run commands just like this. Now let's identify remote users. We do this with the W command, which will display a list of users currently logged into the computer. This is especially useful to show which users are logged in using SSH from which remote locations and what they are doing. So I'll type W command and get a list of these users. This output will show that the user Shumi is logged into the system on the pseudo terminal, the time this user logged in, and the host address, IP address, and has been idle or performing some commands, for example, W command. Now, SSH secures communication through public key encryption. When an SSH client connects to an SSH server, the server sends a copy of its public key to the client before the client logs in. This is used to set up the secure encryption for the communication channel and to authenticate the server to the client. When a user uses the SSH command to connect to an SSH server, the command checks to see if it has a copy of the public key for that server in its local known hosts file. The system administrator may have pre-configured it in the etc ssh known hosts file, or the user may have their own SSH file, which is located in their home directory in the .ssh directory, and the file name is known hosts. That file will contain the key. If the client has a copy of the key, the SSH will compare the key from the known hosts file for that server to the one it received. If keys do not match, the client assumes that the network traffic to the server could be hijacked or that the server has been compromised, and seeks the user confirmation on whether or not to configure and continue with the new connection. You can restrict this policy even more if you set the restrict host key checking parameter to yes in the user-specific config file, which is located in the user's home directory .ssh directory, or the system-wide directory or file, which is located in etc ssh config file. That will cause the SSH command to always abort the SSH connection if the public keys do not match. Now, if the client does not have a copy of the public key in its known hosts file, the SSH command will ask if you want to log in anyway. If you do, a copy of the public key will be saved in your home directory .ssh directory and known hosts file, so that the server's identity can be automatically confirmed in the future. To show you this procedure, let's try logging in from this server to the server which is unknown for OpenSSH. So I'll type ssh temp at NAS, and we'll get this message that the authenticity of host can't be established. Are you sure you want to continue connecting? And if we do, we can type yes, and we'll get this warning: permanently added this host to the list of known hosts. If a server's public key is changed because the key was lost due to hard drive failure or replaced for some legitimate reason, you will need to edit the known hosts files to make sure the entry for the old public key is replaced with an entry with the new public key in order to log in without errors. Public keys are stored in the etc ssh known hosts file, and each user's file is located in user's home directory .ssh directory known hosts file on the SSH client. Each key is on one line. The first field is a list of host names and IP addresses that share that public key. The second field is the encryption algorithm for the key, and the last field is the key itself. So let's take a look at this file. I'll type cat.ssh/known_hosts, and this will dump known hosts file with all these three key fields I've mentioned. Each remote SSH server that you connect to stores its public key in the etc ssh directory in files with the extension .pub. And it is a good practice to add entries matching a server's SSH host key .pub files to your home directory .ssh known hosts file, or the system-wide etc ssh known hosts file. Now, the last example for this video, let's remove this known host file from our home directory. This will cause SSH to lose the recorded identities of the remote systems. So I'll type rm /home/shumi/.ssh/known hosts. Of course, you shouldn't perform these steps on some production systems, or at least make a backup of this file to restore it. Now, if I try to open the SSH session to the NAS server again, as you remember, we've already added the system to this known host file, but as we removed it, this server will ask me if I'm sure I want to continue connecting to this server, because the system couldn't find this host key for this remote host. Configuring SSH key-based authentication. After completing this video, we'll be able to configure a user account to use key-based authentication to log into remote systems securely without a password. So we can configure a SSH server to allow you to authenticate without a password by using a key-based authentication. This is based on a private public key scheme. To do this, we generate a matched pair of cryptographic key files. One is a private key, the other is matching public key. The private key file is used as the authentication credential and, like a password, must be kept secret and secure. The public key is copied to systems the user wants to connect to and is used to verify the private key. The public key does not need to be secret. You put a copy of the public key in your account on the server, and when you try to log in, the SSH server can use the public key to issue a challenge that can only be correctly answered by using the private key. As a result, your SSH client can automatically authenticate your login to the server without your unique copy of the private key. This allows you to securely access systems in a way that does not require you to enter a password interactively every time. Now, to create a private key and matching public key for authentication, use the ssh-keygen command. By default, your private and public keys are saved in your home directory .ssh directory, id_RSA and id_RSA.pub files, respectively. So let's run this command. We'll type ssh-keygen. Here we have to enter a file in which to save the key. We have to enter passphrase and to enter passphrase again. And we'll take all the defaults. Of course, you can alter this information. And if you do not specify a passphrase, when ssh-keygen prompts you, the generated private key is not protected. In this case, anyone with your private key file could use it for authentication. If you set a passphrase, then you will need to enter the passphrase when you use the private key for authentication. Therefore, you would be using the private key's passphrase rather than your password on the remote host to authenticate. So it's for you to choose, and it depends on the level of security you want to choose. You can run a helper program called SSH agent, which can temporarily cache your private key passphrase in memory at the start of your session to get true passwordless authentication. This will be discussed later in this video. The following example of the ssh-keygen command shows the creation of the passphrase protected private key alongside the public key. So we'll type ssh-keygen-f.ssh/key with pass. In this example, the -f option with the ssh-keygen command determines the files where the keys are saved. In the preceding example, the private and public keys are saved in the home key.ssh, key with path file, and key with path.pub files respectively. Please note that during the further SSH key pair generation, unless you specify a unique file name, you are prompted for permission to overwrite the existing ID.RSA and ID.RSA.pub files. If you override the existing ID.RSA and ID.RSA.pub files, then you must replace the old public key with the new one on all the SSH servers that have your old public key. So please keep it in mind that if you replace it, you have to replace it on all the servers, this old public key with the new one. Once the SSH keys have been generated, they are stored by default in the .ssh directory of the user's home directory. The permission modes must be 600 on the private key and 644 on the public key. And of course, we can share public key. Before key-based authentication can be used, the public key needs to be copied to the destination system. The SSH copy ID command copies the public key of the SSH key pair to the destination system. If you omit the path to the public key file while running ssh-copy-id command, it uses the default home user.ssh id_rsa.pub file. So let's try running the following command: ssh-copy-id-i.ssh/key-with-path.pub to the remote host. For example, we'll use the user temp at NAS host. It can be any host for your testing purposes. In my case, it looks like that. After the public key is successfully transferred to a remote system, you can authenticate to the remote system using the corresponding private key while logging in the remote system over SSH. If you omit the path to the private key while running the SSH command, it uses the default home user.ssh id.rsa file. So let's type ssh-i.ssh/key-with-the-path file and the user, it's for me temp at NAS. And some words about using SSH agent for non-interactive authentication. In case if your SSH private key is protected with a passphrase, as we've discussed earlier, you normally have to enter the passphrase to use the private key for authentication. However, you can use a program called SSH agent to temporarily cache the passphrase in memory. Then anytime that you use SSH to log into another system with the private key, SSH agent program will automatically provide the passphrase for you. This is convenient and can improve security by providing fewer opportunities for someone shoulder surfing to you and type the passphrase in. Depending on your local system's configuration, if you initially log into the GNOME graphical desktop environment, the SSH agent program might automatically be started and configured for you. If you log in on a text console, log in using SSH or use Sudo or SU, you will probably need to start SSH agent manually for that session. You can do this with the following command: eval $, and in brackets SSH agent. Now we are typing this command, the command like this, because when you run SSH agent, it prints out some shell commands. You need to run these commands to set environment variables used by programs like SSH-add to communicate with it, and the eval $SSH agent in brackets command starts SSH agent and runs those commands to automatically set those environment variables for that shell session. It also displays the PID of the SSH agent process. And once the SSH agent is running, you need to tell it the passphrase for your private key or keys. You can do this with the SSH add command. The following SSH add commands add the private keys from home user.ssh id RSA, it's the default, and .ssh key with path files respectively. So to repeat, please type ssh-add. This will add our id RSA key, and please type ssh-add .ssh/key with path file respectively. After successfully adding the private keys to SSH agent process, you can invoke an SSH connection using the SSH command. If you are using any private key file other than the default one, which is home, in my case shumi.ssh id RSA file, then you must use the -i option with the SSH command to specify the path to the private key file. So let's try typing the following command. SSH, in my case it's another test in system, and I'll be using user temp add remote host, in my case it's NAS. And in this example the SSH command uses the home key with path, which is not default, private key file to authenticate to an SSH server. The private key in the following example has already been decrypted and added to its parent, SSH agent process. So the SSH command does not prompt you to decrypt the private key by interactively entering its passphrase. And we successfully log into the remote host without entering interactively our passphrase for this key. Let's run another command, which is ssh-i, and specifying the file we want to use. In this case, it's located in the .ssh directory and its name is key with path, and the user and host name for the remote host. In my case, it's temp at NAS. When you log out of the session that started SSH agent, the process will exit and the passphrases for your private keys will be cleared with memory. And of course, you can read references about the commands like ssh keygen, ssh copy id, ssh agent, and ssh add man pages. In this video we'll be customizing OpenSSH service configuration. And after completing this video, you should be able to restrict direct logins as root and disable password-based authentication for the OpenSSH service. So, as you might know, OpenSSH service is provided by a daemon called SSHD. Its main configuration file is in etc ssh directory, and the file name is sshd_config. This default configuration of the OpenSSH server works well. However, you might want to make some changes to strengthen the security of your system. There are two common changes you might want to make. You might want to prohibit direct remote login to the root account, and you might want to prohibit password-based authentication in favor of SSH private key authentication. And it is a good practice to prohibit direct login to the root user account from remote systems. Some of the risks of allowing direct login as root include the username root exists on every Linux system by default, so a potential attacker only has to guess the password, instead of a valid username and password combination. This reduces complexity for an attacker. Another reason is that the root user has unrestricted privileges, so its compromise can lead to maximum damage to the system. Another reason is that from an auditing perspective, it can be hard to track which authorized user logged in as the root and made changes. If users have to log in as a regular user and switch to the root account, this generates a log event that can be used to help provide accountability. Now, the OpenSSH server uses the permit root login configuration setting in the etc ssh sshd config configuration file to allow or prohibit users logging in to the system as root. And with the permit root login parameter to yes, as it is by default, people are permitted to log in as root. To prevent this, set the value to no. Alternatively, to prevent password-based authentication but allow private key-based authentication for root, set the permit root login parameter to without password. And after you do the changes, the SSH server or SSHD must be reloaded for any changes to take effect. So you have to perform the following command: Systemctl reload SSHD. And the advantage of using a Systemctl reload SSHD command is that it tells SSHD to reread its configuration file rather than completely restarting the service. A Systemctl restart SSHD command would also apply the changes, but would also stop and start the service, breaking all active SSH connections to that host. We can also prohibit password-based authentication for SSH, allowing only private key-based logins to the remote command line, and it has various advantages. Attackers cannot use password guessing attacks to remote break into known accounts on the system. Attackers cannot use this technique anymore. With password-protected private keys, an attacker needs both the passphrase and a copy of the private key. With passwords, an attacker just needs the password. And by using passphrase protected private keys in conjunction with the SSH agent command, the passphrase is exposed less frequently since it is entered less frequently, and logging in is more convenient for the user. The OpenSSH server uses the password authentication parameter in the etc ssh sshd config configuration file to control whether users can use password-based authentication to log into the system. And you have to change this value. The default value of yes for the password authentication parameter causes the SSH server to allow users to use password-based authentication while logging in. The value of no for password authentication prevents users from using password-based authentication. Keep in mind that whenever you change the SSHD config file, you must reload SSHD service for changes to take effect. And please also remember, if you turn off password-based authentication for SSH, you need to have a way to ensure that users' authorized keys file on the remote server is populated with their public key so that they can log in. And of course, you can read references, man pages for SSH, SSHD_config. Now let's go ahead and perform some step-by-step exercises to disable direct logins as root over SSH and disable password-based authentication for remote users to connect over SSH. First, I'll use the su command to switch to Superuser on this server. So I'll type su-shumi and the password for this user. Then I'll type ssh key gen command to generate SSH keys without entering any passphrase for the keys. Now I'll use SSH copy ID command to send the public key of the SSH key pair to Superuser on the remote server, which is in my case SUSE 15. So I'll type SSH copy ID shumi at SUSE 15. Now let's confirm that I can successfully log into the remote server SUSE 15 as Superuser using the SSH keys. I'll type SSH shumi at SUSE 15. Now let's confirm that you can successfully log into the remote server, in my case it's SUSE 15, as root using the password of the Superuser. So I'll open SSH session to SUSE 15 as root using the password, and I'll type SSH root at SUSE 15. And after entering the password, as you can see, I can successfully log in as root, as a Superuser. Now let's configure SSHD on SUSE 15 to prevent users logging in as root. So I'll log in with my own user. It's Shumi. I'll type Shumi, SSH Shumi at SUSE 15. And now I'll switch to root. I'll type su dash, entering the root's password, and I'll set permit root login to no in etc ssh sshd underscore config and reload the SSHD. You may use Vim editor to edit this configuration file. And after completing editing the file, you should reload the SSHD. So you should type Systemctl reload SSHD. Now when trying to log in to this SUSE 15 server as root, you should fail because you disabled root user login over SSH in the preceding step. Now to configure SSHD to allow users to authenticate using SSH keys only rather than their password, please edit the same file sshd config and set password authentication to no and reload SSHD. Again, you may use Vim to edit this configuration file of SSHD. So I'll type Vim etc ssh sshd config, find the parameter, set it to no, then save the file and type Systemctl reload SSHD. Now when I'm done with these two parameters, let me check if it allows user to use the password and allows root user to log in remotely via SSH. And as you can see, the settings are working just fine. And I've successfully prohibited using root account on SSH and using passwords for users to log in on SSH as well. To start Vim, just type vim, Vim. Let's do it. Vim has the special modes. One of them is the insert mode, in which you can type your text, and the other one is the command mode. Most of commands are some letters or numbers. To enter the insert mode, just type a letter I. Let's do it. Check out this information sign in the left bottom corner. It says insert. It means that you're in insert mode. Now you can type your text here. Let's type some text and then we'll have to switch to the command mode to save the file. You can type here whatever you want. Let me also type some text. And now we have to leave the insert mode to go to the command mode. To do this, you just press escape key. Let's do it. Press escape. See, the word insert in the left bottom corner has disappeared. Now we are in the command mode. To give some command to Vim editor, just type colon, and after colon you can give any commands. Let's type a command. In our case, we want to write the file, so we type W. Then we press space and give it a name. I'll name it text1. We can see the notification that our file is written and its name is text1. Now if we've finished editing and creating a file, we can quit Vim by pressing colon again and Q letter. Now to move around the file, you can use the letters. J is the letter to go down. Let's press it several times. So let's press J. As you can see, the cursor goes down. J is for down. K is for up, so let's press it several times. Just press K. As you can see, the cursor goes up. L is for right, so let's press it several times, and as you can see, when we press L letter, it goes right. Let's do it. Let's press it several times. Just press L several times. And H is for left, so press several times H and the cursor will go left. As you can see, it is moving left when we press H button. Let's practice it a bit more. Let's press J to move down. Press K to move up. Press L to move right. And press H to move left. Now let's press I to add some text. Let's type some text here. Press escape and type WQ to save the changes to the file. Let's give it a name, as it is a new file. Let's name it text2.txt and leave. Now let's recap the commands we used in Vim editor, our first commands. So to enter Vim editor, you just type Vim. If you want to edit some already existing file, just type Vim and the name of the file. Now by default, Vim goes in command mode. To enter the insert mode, you just press I. This will show that you use insert mode. Now you can add some text to your file. To go back to the command mode again, just press escape. To move around your text, just press J to move down, K to move up, L to move right, and H to move left. To write the changes to the file, go to the command mode by pressing escape and type write, then the file's name. If you want to write the changes to an existing file, just type write and put an exclamation mark. And to quit, you just write in command mode Q letter. When you start using something, especially something so complicated as Vim, you should know how to get help. So to get help in Vim, you just type in the command line :help, and that takes you directly to the help of Vim. Now let's type :help. Here it is, many topics which could help you in using Vim. And when you are done looking for some help topic, you can just exit from this help to where you were before. You can also use some specific topics. You should type :help and then this topic that you are interested in. You can also try typing help and then begin typing the topic you are interested in. But you just try to start typing and then use tab key. And when you use tab key, Vim proposes you different options which could be used for helping. Let's try typing help in and press tab. So as you can see, tab helps us to find out which topics we are interested in. And you get complete list of all topics you are interested which use ins or insert. So insert could be the case and some other topics. If you want to master VIM or Vim, you have to practice a lot. So let's do our first exercise and create a new file. We have to call it text1. So let's create a file called text1, then insert some text and then save and quit the file. So please do it, and you can check the answer file a bit later. For now you have to pause for some minutes, do this exercise and then check the answer, what commands you have to use to do this simple task. So I hope this was simple for you, and here is an answer. To open a file called text1 in the current directory, you should type v and then the name of the file. In our case it's text1.txt. Then to enter the insert mode you have to press I. This will put you into an insert mode. Then you have to type some text, like this is a text example. Then to return to a command mode you have to press escape. So let's press escape, and then to save your edits just type WQ command. This will save your edits and your new file. I've already said some words about single movements in Vim. Such keys as H, J, K and L. They H left one space, J down one line, K up one line and L right one space. Let's open some example file and move around a bit again. And one more thing to add, you can add numeric arguments to these letters. For example, if you want to move the cursor 4 spaces to the right, you can add 4 to the letter L. Let's do it. Let's type 4 and L fast. It's just as you had typed L 4 times. And the same you can do with other letters. Two useful commands that involve movements within a line are 0 character and $character. 0 digit 0 moves to beginning of line. $character moves to end of line. Let's press now $character and the cursor goes to the end of the line. And let's press 0 character and the cursor goes to the beginning of line. You can also move the cursor by blocks of text, words, sentences, paragraphs. The W command moves the cursor forward one word at a time, counting symbols and punctuation of equivalent to word. And if you don't want to count symbols and punctuation, you can use capital W. This command will move the cursor, so to say, by logical blocks. To move backward by word, use B command, and capital B allows you to move backward by word, not counting punctuation. Now some words about simple edits. When you've added some text to your file, you want to edit it. I for insert, which you've already seen. This will insert some text into your file. A for append, so if you want to append some text, just press A. C for change, and D for delete. You can also combine the commands, like if you want to change not a single word, a single letter, but a word, combine C change command with W for word. You can replace a word CW with a longer or shorter word, and then would be much faster than replacing each letter in this word. To replace an entire current line, use a special change command CC. CC changes an entire line, replacing that line with any amount of text entered before pressing escape. The tilde command will change a lowercase letter to uppercase or an uppercase letter to lowercase. So tilde character changes the case. The DD command deletes the entire line that the cursor is on. DD will not delete part of a line. You can undo your last command if you make an error. Simply press U. The cursor needs to be on the line where the original edit was made. Now let's recap the basic Vim commands. One word actions. To change this one word, just use CW. To delete, DW. To copy, YW. You can add numeric 2 to do this with 2 words. 3 words will be 3, and etc. To move 3 words back, for example, you can use 3CB or C3B. Then to delete 3 words, you can use 3DB or D3B. And to copy 3 words, you can use 3YB or Y3B. As for one line, to change one line, you can use CC command. To delete one line, you can use DD command. And to copy one line, you can use YY command. To go to end of line, you can use capital C. To delete to end of line, you can use capital D. To beginning of line, you can use C0. To delete to beginning of line, D0. And copy, Y0. To change single character, you can use R. To delete, you can use X. And to copy, Y1. That was as for editing commands. As for movements, as you remember, moving left is H, moving down is J, moving up is K, and moving right is L. To move to first character of next line, you can use plus character. To first character of previous line, you can use minus character. To end of word, you can use E, and forward by word, you can use W. Backward by word, you can use B, and to end of line, $ character, and to beginning of line, 0 character. Some other operations. To place text from buffer, you can use P. To save edits, you can use WQ, or just W if you don't want to quit. And to save of edits, quit file without saving, you can use Q exclamation mark. This will quit the command, the Vim editor without saving any changes. As for text creation and manipulation commands, we have insert text at current position. We use I command. To insert text at beginning of line, we use capital I. To append text to current position, we use A command, and to append text at beginning of line, we use capital A. Open new line below cursor for new text, O, and open new line above cursor for new text, capital O. Delete line and substitute text, capital S, and overstrike existing characters with new text, capital R. Joint current and next line, we use capital J. Toggle case, tilde sign. Repeat last action, dot, just dot. Undo last change, U character. And restore line to original state, capital U. Oof, that was hard, and a lot to remember, and a lot of space for practicing for you. There are Vim commands to scroll forward and backward through the file by full and half screens. Ctrl capital F will scroll forward one screen. Ctrl capital B will scroll backward one screen. Ctrl capital D will scroll forward half a screen, down. And Ctrl capital U will scroll backward half screen, up. If you want to scroll the screen up and down, but you want the cursor to remain on the line where you left it, use the Z command. Z enter moves current line to top of screen and scroll. Z dot moves current line to center of screen and scroll. And Z minus character moves current line to bottom of screen and scroll. You can also keep your current screen or view of the file and move around within the screen using capital H. Capital H moves to home, the top of line on screen. Capital M moves to middle line on screen. And capital L moves to last line. You can specify some number of lines before capital H. For example, you can type 5, capital H. This will move to 5 lines below top line. And 5, capital L will move 5 lines above last line. Within the current screen there are also commands to move by line. You've already seen J and K. You can also use Enter. This will move to first character of next line. Plus will move to first character of next line, and minus will move to first character of previous line. Another way that you can think of moving through a Vim file is by text blocks, words, sentences, paragraph. E, as I've already mentioned, will move to end of word. Capital E move to end of word, ignore punctuation. Opening bracket, move to beginning of current sentence. Closing bracket, move to beginning of next sentence. Opening curly bracket, move to beginning of current paragraph. And closing curly bracket, move to beginning of next paragraph. If you want to search for some word in your text, just type slash. When you enter a slash, it appears on the bottom line of the screen. You then type in some word that you are looking for. For example, let's type Ubuntu from capital U. And it will find the word Ubuntu in our text, the first matching word. Now, if there are several words Ubuntu in our text and we want to repeat search in the same direction, we have to press N button. So let's press N and it finds all the results for Ubuntu. In Vim you can also display the current line number on the bottom of the screen. So the command Ctrl G causes the following to be displayed at the bottom of your screen. It shows the current line number, the total number of lines in the file, and what percentage of the total the present line number represents. For example, now you can read that we are using ubuntu.txt, the number of lines in it, and the percentage we are on. And it also shows the line number we are on in the right bottom corner. Now to move to the 44th, for example, line, we can type 44 capital G, and that will get us to the 44th line of our file. Let's check it with Ctrl G. As you can see, we are on 44th line in the beginning of it. Now let's review the Vim motion commands. To scroll forward one screen, we use Ctrl F. To scroll backward one screen, we use Ctrl B. To scroll forward half screen, we use Ctrl D. And sorry, all these letters are capitals. To scroll backward half screen, we use Ctrl capital U. To scroll forward one line, we use Ctrl capital E. To scroll backward one line, we use Ctrl capital Y. Move current line to top of screen and scroll, Z, Enter. Move current line to center of screen and scroll, Z dot. Move current line to bottom of screen and scroll, Z minus. Move to home, the top line of screen, capital H. Move to middle line of screen, capital M. And move to bottom line of screen, capital L. To move first character of next line, we use Enter. And to move to first character of next line, we use plus. You need to practice a bit to master all these movements. So take a look at this table and practice with these commands to be more certain and more sure in moving around in the text in Vim editor. So far you have invoked the Vim editor with the command vim and file name. There are other options to the vim command that can be helpful. You can open a file directly to a specific line number or pattern. You can also open a file in read-only mode. Another option recovers all changes to a file that you were editing when the system crashed. When you begin editing an existing file, you can call the file in and then move to the first occurrence of a pattern or to a specific line number. You can also specify your first movement by search or by line number right on the command line. So if you want to open a Vim editor with on the certain line number, you can try typing vim plus and the line number and then the file name. Let's try opening our file, our testing file, on line number 44. Let's type vim, file name, in our case it's udemy.txt, and then plus 44. That will open our file on the line number 44. Vim file name and then plus, only plus, will open the file at last line. And Vim file name, in our case it's ubuntu.txt, plus slash and the word, the pattern we are looking for. Let's type, for example, Ubuntu, and it will open file at the first occurrence of this word. In our case it's Ubuntu. There will be times when you want to look at a file but want to protect the file from any changes. You can open this Vim editor in read-only mode. To do this you have to type vim the file's name and -R. This will open a file in read-only mode. Or an alternative way doing so is to type view and the file name. The view command, like the vim command, can use any of the command line options for advancing to a specific place in the file. Now some words about saving and exiting files. You already know "-w" command and "-q" command. As you remember, "-w" command writes to the buffer, to the file, but does not exit. You can use "-w" throughout your editing session to protect your edits against system failure or a major editing error. "-q" quits the editor, and "-wq" both writes the file and quits the editor. The write happens unconditionally, even if the file was not changed. "-x" both writes file and exits the editor. The file is written only if it has been modified. So if you have modified some file and don't want to type 2 letters, you can type 1 letter "-x". This will both write the file and quit. Vim protects existing files and your edits in the buffer. For example, if you want to write your buffer to an existing file, Vim gives you a warning. Likewise, if you have invoked Vim on a file, made edits, and want to quit without saving the edits, Vim gives you an error message, such as "no write since last change." These warnings can prevent costly mistakes, but sometimes you want to proceed with the command anyway. An exclamation point after your command overrides the warning. For example, you can type a command ":w!" or you can type ":q!" ":w!" can also be used to save edits in a file that was opened in read-only mode with Vim, when you use "-R" or "view" command. ":q!" is an essential editing command that allows you to quit without affecting the original file, regardless of any changes you made in this session. And the contents of the buffer is discarded. You can also use ":w" to save the entire buffer, the copy of the file you are editing, under a new file name. Suppose you have a file ubuntu.txt, as in our case, which contains lots of lines. You open the file and make extensive edits. You want to quit but also save both the old version of this file and your new edits for comparison. To save the edited buffer in a file called ubuntu new, for example, .txt, you can give a command ":w ubuntu.new.txt". Your old version in the file ubuntu.txt remains unchanged, and you save the new one. You can now quit editing the new version by typing ::q. You can initiate multi-window editing when you start Vim, or you can split windows within your editing session. Multi-window editing is dynamic in Vim, allowing you to open, close, and navigate among multiple windows at any point from most context. So by default, Vim opens only one window for a session, even if you specify more than one file. And multiple files occupy multiple buffers, for each file in its own buffer. To open multiple windows from the command line, use vim -o option. For example, we can type now vim file 1, in our case it's ubuntu.txt, and file 2, ubuntu.new.txt, and then -o. As you can see, it opens the edit session with the display horizontally split into two equal-sized windows, one for each file. For each file named on the command line, Vim tries to open a window for editing. Let's close both of these files, entering :Q for each file. Now let's open ubuntu.txt file again to practice a bit with one file. Take a look at the bottom of the file. When Vim creates more than one window, its default behavior is to create a status line for each window. And the default behavior for a single window is to display any status line. You can control this behavior with Vim last status option. So if you set last status to 2, you will always see a status line for each window, even in single window mode. Please note here, there is no status line now, but when we enter this command, there will be a status line even if we are in single window mode. So let's type set last status equals 2. And as you can see, the status bar has appeared now. You can create a new window with the split command. This breaks the current window in half, showing the same buffer in both halves. Now you can navigate independently in each window on the same file. So let's run this command, :split. And the screen is split and we have the same file in both parts of the window. Or in both windows, better to say. Similarly, you can create a new vertically separated edit window with the :V split. This will split the screen into two vertical windows. Let's run it. :V split. This could be helpful and handy when you when you are writing some shell scripts and need to have both parts of some script accessible to you, and you can compare some parts of the scripts. One part you can use for a template and another for some edits. If you want to edit or browse another file without losing your place in your current file, you can provide the new file as an argument to your :split command. For instance, let's do it now. :split ubuntu.new.txt. Let's open two files simultaneously and try to move around between the files. By default, you cannot do this and your mouse is disabled by default. In Vim, you can enable the behavior of the mouse option, and you can do it with the setting for Vim set mouse equals A. This will activate your mouse for using inside of Vim, so you can use it in command line, input and navigation. If you don't have a mouse or prefer to control your session from the keyboard, Vim provides a full set of navigation commands to move quickly and accurately among session windows. So to move between windows, you can use Ctrl-W command, and this will switch between the windows.